Hi everyone. So as usual, we'll start the lesson at 10. So in 5 minutes, just so that I'm sure everyone came into the lesson and I can start with everyone. Okay, hi everyone, it's 10 o'clock. I'll just make sure my screen is shared. Okay. Okay, perfect. So hi everyone, welcome to this lesson on, so for maths, as you know, it's going to be on simultaneous equations, quadratic equations, and factorizing. So we saw simultaneous equations in October or November, I believe, and it's basically when you have two equations that you need to solve at the same time, and you need to find a solution that fits both equations. So basically, when you have an equation, you need one variable for one equation. If you have one variable for one equation, you can solve for that one variable. However, if you have two variables in one equation, then you have an infinite amount of solutions, and you need a second equation in order to find a solution. So basically, in order to be able to find solutions to your problem, you need at most two variables for two equations. Then if you go into three equations, you can have at most three variables. If you go into four equations, you can have at most four variables. So the most you can have is one variable per equation. If you have more than one variable per equation, you won't be able to solve the problem because it has an infinite amount of solutions. So that's going to be on simultaneous equations. We'll see two methods. We'll see substitution and elimination. One obviously is easier than the other, but I need to show both of them to you because the harder one is going to be very useful when you go into systems of three equations with three variables. So that's why I introduce it in this lesson. It's going to be kind of a reminder from a couple months ago when we did that subject in class. Okay, after simultaneous equations, we'll go into quadratic equations. So how do we go from a linear equation to quadratic equation? It's basically, now you don't have just an x and a constant, you have x to the power of 2. So that's what a quadratic equation is. You go from ax plus b to ax squared plus bx plus c. So you increase the power of x. We'll see how to factorize such equations, and we'll also see how to solve such equations. When you have, for example, a quadratic equation equal to 0, we'll see that there's quite a simple equation to use to find the solutions. And we'll see that depending on the equation, you'll have 1, 2, or no solutions, and we'll link that to the graphs of the different equations. Okay, so let me check if there's no questions at the start. Okay, just put in the chat if everything's fine or if there's an issue. Just quickly, so I make sure I don't start the lesson with a problem. Just say it's good or it's not as good. So as I said last month, there's a 30 seconds delay. So if you write something in the chat, for you, it will seem as if I answer 30 seconds after you put a question. So that's why there's going to be a delay. Okay. Seems to be working fine. Okay, so then I'll start the lesson, and I'll put in big screen. Okay, there you go. So as I said, there's going to be three parts to this lesson. First we'll have, so the contents, first we'll have the solving linear simultaneous equations. So we'll focus on solving linear equations. So linear is where you have where the x and the y, so the two variables, don't have a power to them. So a quadratic equation is when you have x to the power of 2. A linear equation is when you have just x and y. They're not in a function. They don't have a power. It's just x, maybe multiplied by a constant. But that's a linear equation. So that's when you have two equations with two variables that you need to solve at the same time and find a solution for x and y that fits both equations. And as I said before, we'll look at two examples, two methods to solve such equations. We'd say more system of equations because there's two equations, so we'd say a system of equations. Part 2 of this lesson is going to be on solving quadratic equations by factorizing. So first, we'll see by factorizing, and then we'll see using how to solve them using the formula. So basically, it's going to be a review on how to factorize. If we have x squared plus ax squared plus bx plus c, how do we take this and turn it into a multiplication between two brackets? So that's going to be a review on factorizing, and we'll see how we can actually solve equations by factorizing. And finally, the third part is going to be our quadratic formula, maybe a formula you've seen before. And we're going to be using it to solve basic quadratic equations. So in this lesson, I think I have two Microsoft quizzes. Yeah. One after the linear simultaneous equations, and one at the very end of the lesson to review kind of quadratic equations and how to solve them. Of course, as we go on in the lesson, I included some past paper problems and some from the exercise sheet you were given, and also some examples I created myself. Okay, one of the main things that came out of the lessons a month ago was that I should be a bit more interactive, so I'll try to use the chat a bit more this lesson so I can interact a bit more with you guys. Okay, so first part of the lesson, linear simultaneous equations. So why do we need two equations to solve a system of two variables? Well, if we consider equations that have more than one unknown, more than one variable, it can have an infinite number of solutions. For example, 2x plus y is equal to 10. If that's all we have, 2x plus y is equal to 10. It could be solved in many ways. You could have x equal to 2, y is equal to 6, or you could have x is equal to 1, y is equal to 8. You could have x is equal to 4, y is equal to 2. You have an infinite number of solutions. So that's why we need another equation to narrow down the solutions down to a finite number. So we need another equation that maybe uses both variables that will have also an infinite amount of solutions. However, when you put the two together, when you put the two equations together, you need to find which solutions are in common in both of the equations. So that's why, even though if you take them individually, you have an infinite amount of solutions. When you take them both together, you need to find which solutions are in both equations. So which solutions fits both equations at the same time. So that's why we call them simultaneous equation, because we need to find a solution that fits the two equations simultaneously at the same time. So the aim is then to find the solution that fits both equations. We simultaneously solve both equations. This is why we call them simultaneous equations. So just a little note, I'm going to be using these curly brackets. It's when you solve simultaneous equations, you generally use curly brackets to show that you're trying to solve the two equations at the same time. And so, for example, if I have two equations such as 2x plus y is equal to 10 and x plus y is equal to 8, I would write it this way with curly brackets so that it shows I need to solve the two at the same time. And then I could write my answer in this way, curly brackets, x equals something and y equals something. So those are the solutions that I can also write in curly brackets. So that's not so much for now, because there's not such an emphasis on notation and how to write down equations, but it's going to be useful for later on when you go into harder problems. Okay, so wait, Okay. So basically, we need to solve simultaneously both equations. So as I said before, I don't know why this this slide repeated itself. We need another equation to narrow down solutions. We need to solve them simultaneously. For example, here we have, that's going to be the example we use in the next couple of slides to show how to solve them. We have a first equation that we describe as equation 1. And we have another equation that we could describe as equation 2. And you'll see that in how to solve them, we'll be using, we use equation 1 to find equation 2. We use equation 2 to simplify equation 1. So it's important to write the equation number so we know what we're going to use. So the first method, probably the harder one, but the one that's going to be most useful when you go into systems of 3 equations, is the method of elimination. So basically what you're going to do is you're going to use line 1, so you can also say equation 1 and equation 2 in operations to try to get rid of a variable. Because as you can see in this system of equation, we've got 3x plus y is equal to 11 and 2x plus y is equal to 8. So that's our equation 1 and our equation 2. So what happens now if we take equation 1 and we subtract it by equation 2? What if we take this line and we do this line minus line 2? So this is why I write here, line 1 minus line 2. So when you combine 2 lines together, you need to do the operation on the left of the equal sign and on the right as well. So if I do 1 minus 2, I'm going to have 3x plus y minus 2x plus y. Where does this 2x plus y come from? It's from this 2x plus y. It's from line 2. And when we did line 1 minus line 2, we took the left side of line 2. And then for the right side, we have 11 minus 8. Where does this minus 8 come from? It's from the 8 to the right of the equal sign in line 2. Okay, so what does this become? What we notice is when we do 3x plus y minus 2x plus y, is that the y will cancel out. So this is a way, this method is to get rid of one of the variables such that we only have one variable left in the equation. So when you get rid of the y, you only have an x variable remaining, and you can find the value for x. So we have 3x plus y minus 2x plus y. 3x minus 2x is simply x, and y minus y cancels out, so the y's disappear in that equation. And on the right side, we have 11 minus 8. 11 minus 8 is 3. So in the end, we have x is equal to 3. So this is all by doing line 1 minus line 2. I noticed that in both lines I had y and y. So if I do one minus the other, the y's will cancel out and we can solve for x. So then line 2 didn't change because we didn't really change it up until now. But now that we have value for x, we can plug it into the equation 2. We have x equals 3 and 2x plus y equal 8. But we know that x is equal to 3, so 2x is simply equal to 6. So when you put 6 the other side of the equal sign, it's 8 minus 6, so y is equal to 2. So this method of elimination is by using both lines and doing basically operations between them to get rid of a variable. As you can see, we were able to eliminate y, the y variable, in the first line, in line 1. So of course, it doesn't need to be as simple as 1 minus 2. It could be line 1 minus 2 times line 2. It could be 3 times line 2 plus 3 times line... Oh, that doesn't make sense. That's a mistake, sorry. That would be useless. It could be line 1 plus 4 times line 2. So it doesn't just need to be you use line 1 and line 2. You can actually multiply the lines to in order to get rid of the variable. For example, if I had 3x plus 2y and 2x plus 2 and 2x plus y, I would do line 1 minus 2 times line 2, such that the y's cancel out, and I make sure that it's going to be the y's disappear in my equation. So this method can be a bit more confusing and maybe a bit harder to do, and a bit longer as well. But it is a very important method for later on when you go into systems of 3 equations. Then you're going to have to use the method of elimination. There's no other way. So it's good to practice in advance. So as I said before, we were able to eliminate the y variable in line 1. We did that by doing line 1 minus line 2. And now all we have is x is equal to 3 in line 1. So now that we have x is equal to 3 in line 1, we can use that line to solve for y. Because of course we have x is equal to 3, but you also have 2x plus y is equal to 8. So we can then substitute the value of x into line 2 to find y. So line 1 remains x is equal to 3, but we plug the value of x into, I should probably put it here, we plug the value of x into line 2, because we know x is equal to 3. Instead of using x in line 2, we can just use 3. So 2 times x becomes 2 times 3, which is 6. So 6 plus y is equal to 8. You bring the 6 to the other side. It's y is equal to 8 minus 6. And your solution is x is equal to 3 and y is equal to 2. So of course this was a rather simple example, because we had from the start, we had just y in line 1 and y in line 2, meaning that when we did line 1 minus line 2, the y's immediately cancelled out. But you could have more difficult example where you need to add coefficients to the lines in order to get rid of certain variables. Okay, so this was the first method for elimination. So, of course, an important part of solving a system of equations is to verify your results. Because of course, these calculations can last quite a long time. This problem can go on for a long time if you've got a difficult problem. So it's always good to verify your results at the end of, once you're done, you have your x and your y, you plug it back into the initial equations just to verify that it does fit both equations. So once you're done with your simultaneous equations, try to plug in the values you found in the initial equation to verify if your solution works. So in our previous example, we found x is equal to 3 and y is equal to 2. So now we can try to plug the value for x and that value for y into our initial equations to check if it works. So our initial equations were 2x plus y is equal to 11 and 3x plus y is equal to 11 and 2x plus y is equal to 8. So if you plug the value for x and the value for y, we have 3 times 3, which is 9, plus 2, which is 11. So it does fit the first equation. Now let's check if it fits the second equation. 2 times x is 2 times 3, so 6, plus y is equal to 2, so 6 plus 2 is indeed equal to 8. So we see that our solution works, and it does indeed fit both equations. So the solution x is equal to 3 and y is equal to 2 is a solution to the system of equations we've introduced at the start of this example. So now what does this mean graphically? Because of course we're using x's and y's, so could we potentially draw it as a line or as a plot on a graph? Could we plot a graph and see what the solution is, instead of calculating what the solution is using either the method of elimination or substitution, as we'll see in the next example? Is there any way to see what the solution is? Well, there is by using a more graphical approach, just by observing what each of those graphs are. So here I drew, so on a software online, equation 1 is 3x plus y is equal to 11. So 3x plus y is equal to 11 is the one in green, but 3x plus y is equal to 11. If I bring the 3x to the other side, we have y is equal to 11 minus 3x. So if we look at the gradients of equation 1 of the green line, we see that indeed the gradient is minus 3. Every time it takes one step in the x direction, it takes 3 steps downwards in the y direction. So that's for the green line. Now for the blue line, we can bring the 2x to the other side. We have y is equal to 8 minus 2x. If we look at the graph, we see that it does indeed have a gradient or slope of minus 2. Every time you take one step in the x direction, you take 2 steps downwards into y direction. So that's why the slope is minus 2. Okay, now if we want to fit, if we want to find a solution for both equations at the same time, we need to find a point that is at the same time on the green line and also on the blue line. So the aim of solving this equation is find a point that is at the same time on the green and on the blue lines. So we want to find a point that at the same time fits the green line, so that is somewhere along the green line, but also somewhere along the blue line. So the only point that fits both equations is at the intersection. So where the two lines cross, because where the two lines cross, it's one point that the two equations have in common. And what do we notice? This solution is x is equal to 3 and y is equal to 2. So solution is x is equal to 3 and y is equal to 2, which you could also write as coordinates as 3, 2. And this is exactly the answer we found using our method of elimination. So if you have an exercise where they say don't calculate the solution but draw it graphically, that's what you need to do. You need to plot the two equations on the same piece of paper and find what the intersection of the two lines is. And that's how you find the solution to the simultaneous equations, because basically that point, x equals 3 and y equals 2, is the one that fits both equations at the same time. It lies on the green and on the blue line at the same time. Okay, solve the simultaneous equations below. So just to make sure everything's clear and there's no questions so far, I'll just go in the chat. And could you guys to solve that equation for me, 1a, and put your answers in the chat. Okay, so what website did I use for the graph display? That's quite a good question. I just published that one. It's GeoGebra. So it's very useful if you don't have a graphic calculator. You can just go on GeoGebra, as I wrote in the published part of the chat, and you'll be able to plot graphs. It's very useful. So it's not only straight lines; it can be any graph. So that's why it's really good. Okay, I've got x equals 1, y equals 2, x equals 1, y equals 3. So you seem to agree on x equals 1. Y equals 2. Okay, seems to be x equals 1 and y equals 2. Okay, so let's do it together to see if that is indeed the solution. So we've got two equations. We've got 6x plus 3y is equal to 12. That's our equation 1. And 2x plus 6y is equal to 14. That's our equation 2. So let's imagine we want to eliminate y in line 1. We could choose to eliminate x in line 1, but let's say we want to eliminate y in line 1. So what are we going to do in order to, how do we use line 2 in order to eliminate y in line 1? So line 2 remains the same, 2x plus 6y is equal to 14. And if we look at the two equations, we have 3y and 6y. So I could do 2 times line 1 minus line 2 in order to eliminate y. So that's what I'm going to do. 2 times line 1 minus line 2, and line 2 stays the same. So if I do 2 times line 1 minus line 2, I've got 6x times 2 is 12x, plus 3y times 2 is 6y, minus 2x plus 6y. And this is going to be equal to 2 times 12, which is 24, minus 14, which is 10. Okay, so immediately you notice that 6y minus 6y cancels out, and you've got 12x minus 2x. 12x minus 2x, which is equal to 10x, is equal to 10. So this you can find as x is equal to 1. And we still have the second equation to solve. So we found the first solution. We found the x value for this solution. Now all we need to do is use that x value, plug it into the second equation, and find the value for y. So we've got x equals 1, and 2 times 1 plus 6y is equal to 14. So 2 times 1 is 2, you bring the 2 to the other side, 14 minus 2 is 12, so 6y is equal to 12, so y is equal to 2. So indeed, as you said in the chat, x is equal to 1 and y is equal to 2. Okay, solve the simultaneous equation below. 2x minus 6y is equal to 16, and 3x plus 2y is equal to 5. So I'll solve this one, and then the next one you'll solve yourself. Okay, solve the simultaneous equation below. So similarly to before, I have a system of equations with equation 1 and equation 2. Okay, so let's say this time I'm going to change my method, and I want to eliminate the x variable in line 1. So how can I eliminate the x variable? in the first line, I've got 2x, and in the second line, I've got 3x. So what I could do is do 3 times line 1, so that I get 6x, minus 2 times line 2, such that I get 6x minus 6x, and the 2 cancel out. So that's what I'm going to do. I'm going to have 3 times line 1 minus 2 times line 2. And then line 2 just stays the same. So line 2 is still 3x plus 2y is equal to 5. And the first line becomes 3 times line 1. So I've got 6x minus 15y, because I did 3 times line 1. Minus 2 times line 2. So I multiply line 2 by 2. I've got 6x plus 4y. So that's on the left side of the equal sign. Now, if I want to solve the equation, I also need to do it on the right side of the equal sign. 3 times 16 minus 2 times 5. 3 times 16 is 48, minus 10 is 38. Okay, 6x minus 6x just cancels out. And we have minus 15y minus 4y. So that becomes minus 19y is equal to 38. And then we still have 3x plus 2y is equal to 5. If we solve for y, minus 19y is equal to 38. We divide by minus 19 on both sides. We see that 19 fits twice in 38, but there's a minus sign, so y is equal to minus 2. Okay, so we've got a value for y. Now all we need to do is plug the value for y into the equation 2. So we have 3x plus 2 times minus 2 is equal to 5. So y is equal to minus 2. And x, 3x minus 4, you bring the minus 4 to the other side. So that becomes 5 plus 4 divided by 3. It becomes x is equal to 3. Generally, you'd write the x first, so let's rewrite this correctly. X is equal to 3 and y is equal to minus 2. And that's the solution for our simultaneous equation. So now let's just check our result, make sure that it works. For line 1, we have 2 times 3 minus 5 times minus 2. So that becomes 6 plus 10 and is indeed 16. For line 2, we have 3 times 3 plus 2 times minus 2. So 9 minus 4, which is indeed 5. So this solution works. It gives the right value, 16 and 5 in both cases. Okay, can you guys try question 4? So this time what you're going to need to do is find the 2 variables. So here we don't have an explicit equation. We need to find which item or which thing I'm going to set the variable x to be, and which thing I'm going to set the variable y to be. So you're going to need to choose which how you're going to set your variables, and then construct your equations based on the information you have and which variables you set. So try to solve equation question 4. In the meantime, I'll quickly do a I'll quickly draw a graph so you can see the solutions. Well done to everyone that had the right answer before. I have a question in the chat. If you were given a question on graphical simultaneous equations, would you give the solutions where both the lines intersect? Exactly. That's exactly what it means. If you solve them at the same time, you need to find the points where the 2 lines intersect. Okay, some people saying that I'm going a bit too fast. So this last question, question 4, I'll go a bit slower in the step-by-step reasoning, so that I make sure you understand, everyone understands. Okay. I'll just wait a bit more just to make sure everyone's done with the question. In the meantime, I'll quickly create a graph so I can show you the solutions graphically. Okay, everyone seems to be done with that question. Okay, let me just share my screen to show you how do we solve graphically. So in question 1b, we had the first equation being 2x minus 5y is equal to 16, and I had 3x plus 2y is equal to 5. Those were the two equations I was given. I was given those two equations. So then we can also solve. So of course we use the method of elimination, but we can also solve graphically. So this is what I do here. I have here my second equation and here my first equation. And if we look at the point of intersection is 3 minus 2. X equals 3 and y is equal to minus 2. And that's exactly what we found in by doing the calculation. We found x is equal to 3 and y is equal to minus 2. This is the point that fits both equations. Okay, let me get back to the presentation. There we go. So sorry if I went a bit fast up until now. I'll try to go a bit slower from now on and explain really step by step. Okay, so question 4, we have Sophie is selling student and parent tickets for school performance. One night she sells 50 student tickets and 80 parent tickets and makes £340. On night 2, she sells 25 student tickets and 50 parent tickets and makes £200. What is the cost for one student ticket and the cost for one parent ticket? So let's say, so first thing we need to do is introduce our variables. Let's say that x is the price of a student ticket. And let's say that y is the price of a parent ticket. Now that we've introduced our two variables, we can build our system of equations. We know that when she sold 50 student tickets, so 50 times x, and 80 parent tickets, so plus 80 times y, she made £340. So 50 times the price of a student ticket plus 80 times the price of a parent ticket is equal to 340. Now, on night 2, because she didn't change the prices, we can assume that it's still x and y. So she sells 25 student tickets, so 25 times x, and she sells 50 parent tickets, so 50 times y. And she makes £200. So we've done our first step. We've introduced the variables, we've named the variables. We've done a step 2, which is to build our system of equations with equation 1 and equation 2. Now, step 3 is going to be to actually solve the system of equation. Okay, so once again, we'll use the method of elimination, as we've seen in the previous slides. So let's say we want to, we see that we have 50x and 25x. This is going to be quite easy to eliminate, to cancel out, because 50 is 2 times 25. So if you just multiply by 2 line 2, you'll get 50x as well, and if you subtract, they will just cancel out. So let's say I want to eliminate x in line 1. Because I see that it's 50x in line 1 and 25x in line 2, I can easily eliminate the x's. Because if I do line 1 minus 2 times line 2, I have 50x minus 2 times 25x. So I have 50x minus 50x, and the x's will just cancel out, and all that will be left is the y's, and I can then easily solve for y. So if I do line 1 minus 2 times line 2, I have 50x plus 80y, so that's just line 1, minus 2 times line 2. So 25x times 2 is 50x. And 50y times 2 is 100y. I just put that to the side a bit. 1 minus 2 times line 2. So that's on the left side of the equal sign. Now if we want to solve on the right side of the equal sign, we have line 1, so 340, minus 2 times line 2. In this case, line 2 is 200. 2 times 200 is 400. And then line 2 just stays the same. 25x plus 80y is equal to 200. Okay, if we look at the first line, 50x plus 80y minus 50x plus 100y, we notice that the x's will cancel out. We have 50x minus 50x, they just disappear. Just notice we have the minus sign here. So then 50x minus 50x disappears. All we're left with is the y's. We have 80y minus 100y. What is 80 minus 100? Is minus 20y. So that's on the left of the equal sign. Now on the right, we have 340 minus 400. That is equal to minus 60. And let's say that the second line doesn't change, still 25x. We'll look at this one later on. Stays the same for now. Okay, so minus 20 times y is equal to minus 60. We can just divide by minus 20 on both sides. Minus 20 divided by minus 20 is simply 1. And minus 60 divided by minus 20, the minus signs cancel out. We have 60 divided by 20, which is simply equal to 3. So we have y is equal to 3. We can then plug in the value for y in the second equation. We have 25x plus 80 times 3 is equal to 200. So we have y is equal to 3, and then 25x plus 80 times 3 is equal to 200. 80 times 3 is 240. I'll bring the 240 to the right side of the equal sign, so I do minus 240. I have 200 minus 240, so I have 25. Oh, excuse me. I have 25x is equal to 200 minus 240. Well, I've done a mistake somewhere. Oh. Yeah, I did make a mistake. Wait. Yeah, here. It's actually, it's not 80, it's 50. You might, sorry, I can't see the chat at the same time, so you might have noticed it from the start, but I didn't notice. So it's not actually 80 times 3, it's 50 times 3. So when you bring it to the right-hand side, it's minus 150. Sorry, that's a stupid mistake. So that makes more sense because now 200 minus 150 is simply equal to 50. So 25x is equal to 50. That means that x is equal to 2. So as you said in the chat, x is equal to 2 and y is equal to 3. So a student ticket is £2 and a parent ticket is £3. So I hope that was slow enough. I'm sorry for the little mistake. It didn't impact the reasoning in any way, but I hope this made sense in the reasoning. And you get an answer of £2 for a student ticket and £3 for a parent ticket. Okay, so that was for question 4. And that was essentially all the examples for the first method, which was on elimination. If we now look at the second method on substitution, that's a method you might like a bit more. It's basically using expressions in lines 1 and 2 to create a new equation with only one variable. So if we use the same example, we have 3x plus y is equal to 11 and 2x plus y is equal to 8. So what happens if we rearrange the two lines to get an expression for y? So instead of having 3x plus y is equal to 11, I have y is equal to 11 minus 3x. And for line 2, I have y is equal to 8 minus 2x. So I have basically two expressions for y. I have y equals 11 minus 3x, and y is equal to 8 minus 2x. So of course we can equate line 1 and 2 because we have y is equal to y, we must have 11 minus 3x is equal to 8 minus 2x. Because we want to find a solution where that fits both equations, we know that y is going to be equal to y, of course. So we can equate 11 minus 3x and 8 minus 2x. This is what I do here. And this creates a new equation. A new equation where you combined the two lines together. And what does this new equation have? It only has one variable. It only has the variable x. So you can then rearrange the equation. You bring the 3x to the right side, the 8 to the left side, and you're left with x is equal to 3. So that's the method of substitution. You basically substitute y with another value. As you can see here, y is equal to 11 minus 3x. So I can simply plug in 11 minus 3x into the y that's here. So I substitute y with another expression using only one variable. So of course, this is quite an easy example because you don't have any fractions, you don't have any coefficients in front of y. So that's why it's quite easy to use substitution. It's probably easier than using elimination. So now that we have the value for one of the variables, you saw we found value for x. All we need to do is the same thing as method 1. We just substitute in one of the equations to find the other variable. So you can use either line 1 or line 2. You've got x is equal to 3. So let's say we use line 2. So I plug in the value for x in line 2. I find 2 times 3 plus y is equal to 8. And that gives me y is equal to 2. So in both cases, we would have gotten the same result. Imagine we use line 1. We would have gotten 3 times 3 plus y is equal to 11. So that is 9 plus y is equal to 11. So y is equal to 2. So you see that we get the same results regardless of which expression we use, because once again, it's a simultaneous equation. So regardless of which expression you use, it should give you the same result because the solution is supposed to fit both equations. So if we use line 2, we got y is equal to 2. The same with line 1, we also got y is equal to 2. So the main part of the work is actually finding the first variable. Once you have the first variable, all you need to do is plug in the value for that variable and find the second variable. So once you've found the first variable, it's quite easy to find the second variable. And then of course at the end, once you found x is equal to something and y is equal to something, you can verify your results and plug it into the initial equations you had at the start. Okay, so what I'm probably going to do is, let me check the time a second. Okay, 10:50. So let's do this question. Let's do the little Microsoft quiz, and then we'll have a small 5-minute break. So Andrew goes to the shop to buy some apples and bananas. He goes to purchase 5 apples and 4 bananas, and the total comes to £5.70. Unfortunately, he doesn't have enough money, so he puts back 1 apple and 2 bananas. The total now is £3.60. What is the cost of 1 apple and the cost of 1 banana? So in this example, we'll use the method of substitution just to vary a bit the different methods. So let's say that x is price of an apple, and y is price of, you guessed it, a banana. Okay, so now we did the first step, we introduced our variables. The second step is to build our system of equations. So what is the first equation? So we expect there to be 2 equations such that we'll be able to solve the system of equations. So 5 apples and 4 bananas. 5x plus 4y, that costs 5.70. That's the price of 5 apples and 4 bananas. So he doesn't have enough money, so he puts back 1 apple and 2 bananas, and the new total is 3.60. So the price of 1 apple and 2 bananas, so x plus 2y, the price of those two is the difference between 570 and 360. Because initially he has to pay 570, but then he decides he needs to put back 1 apple and 2 bananas, and that goes down to 360. So the difference between 570 and 360 is the price of 1 apple and 2 bananas. So that price is £2.10. Okay, so we've got our 2 equations. We've got 5x plus 4y is equal to 570. That's from the initial information we have. 5 apples and 4 bananas cost 570. And the second piece of information we have is that if he puts back 1 apple and 2 bananas, so 1x and 2y, the price drops by 2.10. That means that necessarily the price of 1 banana, 1 apple and 2 bananas is going to be £2.10. Okay, so let's rearrange line 2. So we got line 1 and line 2. Let's rearrange line 2 such that we have x is equal to something. So substitution, there's many ways you can have substitution. But here I'm going to show you another way you can have substitution. So I'm going to have 5x plus 4y is equal to 570. This doesn't change. But I'm going to rearrange line 2 to have x is equal to 2 pounds 10 minus 2y. So all I did is bring the 2y to the other side. But now, as you can see, I've got an expression for x as a function of y. So I can just plug that into y, because x is equal to 2 pounds 10 minus 2y. I can replace x with 2 pounds 10 minus 2y. So what does this give me? I have 5 times 2 pounds 10 minus 2y plus 4y is equal to 570. But as you can see from this equation, we only have one variable, so we can solve this equation for y. So what I did here is I replaced x with 2 pounds 10 minus 2y, because x is equal to 2.1 minus 2y. So then I can simply solve for y. So 5 times 2 pounds 10 is 10.5 minus 10y plus 4y is equal to 5.7. So I leave the y's to the left and the constant to the right. Minus 10 plus 4 is minus 6, minus 6y. 5.7 minus 10.5 is minus 4.8. So here all I did is combine the y's together and, and I brought the 10.5 to the right side by subtracting. So 5.7 minus 10.5 is minus 4.8. The minus signs cancel out and you're left with y is equal to 4.8 divided by 6. And 4.8 divided by 6 is simply 0.8. So the price of a banana is 0.8 pounds. Now let's use line 2 to find the price of an apple. In line 2, we have x plus 2y is equal to 2.10. So we have x plus 2 times 0.8 is equal to 210. So 2 times 0.8 is 1.6. So x plus 1.6 is equal to 2.1. 2.1 minus 1.6 is simply 0.5. And there we go, we have our solutions. The price of an apple is 0.5 pounds, and the price of a banana is 0.8 pounds. We can then check our solutions by plugging in the values in the initial equations, but I'll let you do this because I don't have enough space on my PowerPoint. But you can check and make sure that it's indeed the right answer. Okay, so that's on substitution and how it's different to elimination. Okay, let's have a small Microsoft quiz on simultaneous equation, and then we'll have a small 5-minute break. Okay, there seems to be a bit of confusion about the way I did the other, the previous equation. I'll answer your questions just after the quiz, because the way I did it is fine as well, but the way you did it is fine as well, of course. Let me show you after this quiz. So it doesn't matter which equation you substitute the x or y variable. No, it doesn't, because at the end of the day, the equation needs to fit both equations. So if it fits both equations, it doesn't matter which one you use. So for the second equations in the previous example, let me show you. So in this example, most of you said, well, he put back 1 apple and 2 bananas. So now he's left with 4 apples and 2 bananas. So the second equation should be 4x plus 2y is equal to 3.60. That is true as well. There are actually 3 equations you can use here. But what I did is he put back 1 apple and 2 bananas. So he put back, there are 3 items he put back, 1 apple and 2 bananas. And when he put back those items, the price dropped by 2.10 pounds. So what I did is then the price of 1 apple and 2 bananas is necessarily 2.10 pounds, because the price dropped by that amount when he removed those items. But obviously you can also do it in the way most of you guys did it, which is that he removed 1 apple, so now he has 4 apples, and he removed 2 bananas, so he now has 2 bananas. So 4x plus 2y is equal to 3.6. But that's right as well. Both equations work. It's just a different way of seeing it. So can you choose which method to use for any question? Yes, of course, unless they mention use elimination or use substitution. You can use any method you prefer. Okay, let me just go on Microsoft Forms. Okay, I've got 72 answers. I'll just wait a bit more to get a bit more answers. Okay. Just waiting a bit more, because I see that there's 160 students in the call, so I expect a bit more answers than just 80. If we could reach 100, that would be good. Okay, yeah, 86, I guess it's good enough. Let me share my screen. There you go. Okay, so this Microsoft quiz is on simultaneous equations. The first question is, are there any solutions to the simultaneous equations shown in the graph? So you have a graph attached to the question. Yes, in x equals -2 and x equals 2. Yes, somewhere else. No, we don't know, the image doesn't show the whole graph. So if you look at the two lines, the two linear equations, you see that they both have the same gradient. When you go from -2 to 2, so when you go 4 steps in the x direction, it goes 2 steps in the y direction. So it has a gradient of 1/2. Every 1 step it goes in the x direction, it goes 1/2 a step in the y direction. And if you look at the purple graph, it's the same. When it goes 4 steps forward, it goes 2 steps up. So what can we say about the two graphs if they have the same gradient? Well, if they have the same gradient, we can say that they are parallel. They are parallel, so will they ever intersect if they are parallel? Imagine you have two parallel lines, will they ever touch each other? Well, no. So the answer is no. Are there any solutions? No, there are no solutions because the two lines are parallel and they will never intersect. And even if the image doesn't show the whole graph, we don't need the whole graph to know that they won't intersect, because we see just from this portion of the graph that they have the same gradients, so they won't ever intersect. Question 2, what is the solution to the simultaneous equations shown in the graph? Is it there are no solutions? Is it x equals 0 and y equals 6? Is it x equals 3 and y equals 0? Or is it x equals 2 and y equals 2? Well, this isn't a solution. This isn't a solution, or this isn't a solution. The solution is when both lines, both equations intersect each other, because that point, the point of the intersection, is the point that fits both equations. It's the point that is both on the green line and on the gray line. So the solution is indeed x is equal to 2 and y is equal to 2. Finally, question 3, what are the solutions to the simultaneous equations x plus y is equal to 0 and 2x is equal to -2y? So this was a trick question because x plus y is equal to 0 and 2x is equal to -2y are actually the same two equations. Imagine 2x is equal to -2y, you bring the -2y to the left side. So that becomes 2x plus 2y is equal to 0. If you divide by 2 on both sides, you're left with x plus y is equal to 0. So the second equation, this equation, actually doesn't bring any more information into the question. It's actually the exact same equation. So x plus y is equal to 0 and 2x is equal to -2y are actually the exact same equations. So if they are the exact same equation, that means that it doesn't provide any more information. It's exactly the same one. And we know that for one equation with two variables, there's an infinity of solutions, an infinite amount of solutions. So for this simultaneous equations, there is an infinite amount of solutions. Yeah, of course, as x is equal to 0 and y is equal to 0 is one of the solutions, but it's not the only one. There's an infinite amount of solutions. So if we look at the answers, first one, 78% got the right answer. Second one, 85% got the right answer. And third one, a bit of a trick question, is only 42% of you guys got the right answer. Yes, x is equal to 0, y is equal to 0 is a solution, but it's not the only one. If you think about x is equal to 1, y is equal to -1, it's also a solution, for example. Okay, let's have a small 5-minute break until 11:15. and then we'll get back and start quadratic equations. Okay, so doesn't seem to be any questions in the chat, which is good. And just wait one more minute just in case people are not in a call. maybe what I could do is send a form. Okay, let's start the lesson again. So I just put up a link in the published part of the chat. That's for any feedback that you have. So unfortunately, it's my this weekend is my last lessons, or my last lessons with Arithmetics. I won't be giving the May lessons as I have exams. But if you have any feedback, it's always good to know for the future and maybe for next year if I continue to teach with Arithmetics. Okay, so let's continue the lesson. So let me make sure my screen is shared. Okay. So I just had one question regarding question 4. Someone found a solution that fits the first equation. So 50 times x plus 80y is equal to 340. So her or their solution works for the first equation. However, it doesn't fit the second equation. So when you verify your results, make sure that you try it out for both equations. You find, you check with the first equation, okay, it works. And you check with the second equation, okay, it works. So if it fits both equations, then my solution is correct. If it only fits one of the equations, then it's not the right solution. You need to find something else. Okay, let's go into factorizing quadratic equations. I hope everyone's back on the call now. So remember, we have, let me check the time. We have a lunch break in about an hour and 10 minutes now. So what I'll do is I'll go through a bit of how to factorize quadratic equations and a bit of how to use them to solve quadratic equations. Then we'll have the lunch break, and then after the lunch break, we'll go through the quadratic formula. So hopefully I have the right timing this time. We'll see. And we can do also the second Microsoft quiz. So factorizing a quadratic equation. First of all, what is a quadratic equation? So we've seen before an example of a first order polynomial. So that's, you would say, a linear equation. Let me just write a linear equation. So where basically you have ax plus b. So you have a certain coefficient times x plus a certain constant. So what is this? This is basically a straight line. If you think about the graph of this function, that's a straight line. So that would be a linear equation. It's also defined as a first order polynomial. So why do we say first order? Because it's where the power of x is equal to 1. So x to the power of 1 is first order polynomial. The second order polynomial is shown here. It's ax squared plus bx plus c. That is defined as a quadratic equation. So the graph of such an equation we've seen in a previous lesson is not a straight line, it's a parabola. Parabola. There you go. So it's that strange curved shape that can either be looking up or looking down, depending on the sign of a. This is something we've seen in a previous lesson. So that's defined as a second order polynomial equation. Why second order? Because the power of x is 2. Well, the highest power of x is 2. So the first order is just a straight line. It's a linear equation. Second order is a quadratic equation. It's with x to the power of 2. So that's the first definition of quadratic equation and the way kind of what it looks like. So in order to factorize a quadratic equation, we aim to get an expression of the form x plus a times x plus b, because the aim of factorizing is having a product. To factorize is to have two factors, so to have a product of two brackets. So the aim is to have something of the form x plus a times x plus b. If we expand the expression x plus a times x plus b, we get, so we first multiply x times x, x times b, a times x, a times b, so we get x squared plus ax plus bx plus ab. Ax plus bx we can factorize to have a plus b times x. So the final expression for x plus b times x plus a times x plus b is x squared plus a plus b x plus ab. So if you have a quadratic equation, you need to find a and b such that you can factorize it. So for example, if you have an example of x squared plus 2x plus 1, you need to find a and b such that a plus b is equal to 2, a and a times b is equal to 1. So here the answer would be a is equal to 1, b is equal to 1, such that a plus b, 1 plus 1 is equal to 2, and a times b, 1 times 1 is equal to 1. So this is something we'll see with examples, especially. But here we also need to note that the coefficient in front of x squared is 1. If we use this method by imagining x plus a times x plus b, the coefficient we get in front of x is simply 1. So if you need to factorize something that doesn't have something that has something else, something different to 1 in front of the x squared, you're going to need to use another method, which is one we'll see in a couple slides now. So this method will work for any polynomial that has a factor of 1 in front of the x squared. If it has something different, you need to use a different method. Okay, so if we have an example, we want to factorize x squared plus 3x plus 2. So we want to factorize as x plus a times x plus b. We notice that the number in front of x squared is simply 1, so we can use our method. So x plus a times x plus b, it expands as x squared plus a plus bx plus ab. So a plus b, that's what's in front of our x. So a plus b needs to be equal to 3, because that's the number that's in front of the x. And our AB, that's our constant, needs to be equal to the 2. So in this case, the product of A and B needs to be equal to 2, and the sum of A and B needs to be equal to 3, such that when you have A plus B, it equals 3, and when you have A times B, the product, it equals, sorry, not 3, but 2. If you fit those two conditions, you have x squared plus 3x is plus 2, which is exactly what you have at the start. So what are two numbers, a and b, that the product of the two equals 2 and their sum equals 3? Well, you can immediately notice that that is a is equal to 2 and b is equal to 1. So of course you could also say A is equal to 1 and B is equal to 2. The two are interchangeable. You can have A is equal to 2, B is equal to 1, or A is equal to 1 and B is equal to 2. It's the same thing, because at the end of the day, a multiplication, you can switch the order and it doesn't change the value. So what does that mean that A is equal to 2 and B is equal to 1? That means that in our expression here, we can replace A by 1 and B, sorry, A by 2 and B by 1. So we can factorize x squared plus 3x plus 2 as x plus 2 times x plus 1. And if we expand this expression, x times x, x times 1, 2 times x, 2 times 1, we get x squared plus x plus 2x plus 2, which is indeed equal to x squared plus 3x plus 2. So that's another way of verifying. We saw before when we solved simultaneous equations that we always need to verify the results at the end of solving the problem. And here's the same thing. We find A and B such that the product is equal to 2 and the sum is equal to 3. It's always good to verify that the factorization, the way we factorized the expression, indeed works. So we try to factorize, then we expand it again, and notice that it gives us the same result as before. So that's another way of verifying the result. So this method works for when you have a coefficient of 1 in front of the x squared. You find two numbers such that the product is equal to 2 and the sum is equal to 3. So that's in this case, because in other examples you have other numbers, and then you can factorize, find A and B and factorize based on that. So of course x plus 2 times x plus 1 is the same as x plus 1 times x plus 2. So that's why A and B are interchangeable. You can have one is equal to the other and the other is equal to that one, because the order doesn't really change. Okay, so that was for the first example. So now, what if the coefficient of x squared is not equal to 1? So here we have an example, 6 times x squared plus 13 times x plus 6. You see, the coefficient in front of x squared is not equal to 1, it's equal to 6. So the method is you multiply a and c together, because as we defined a quadratic equation, we said that the quadratic equation is ax squared plus bx plus c. Careful that the a and b are different to the a and b we defined before. It's different a's and b's. You could name it differently, but generally we have ax squared plus bx plus c. So the method is you multiply a and c together. So a in this case is 6 and c is 6 as well. You multiply the two together and you get 36. Now you need to find two numbers whose sum is equal to 13, so equal to b, so 13, and whose product is equal to a times c. So you need to find two numbers. Let's call them, how can we call them? M and n, let's say. We need to find m and n such that m plus n is equal to 13 and m times n is equal to 36. So it's a different method. Before we said we need to find two numbers whose sum is equal to this factor in front of x and the product is equal to the constant. But now that we have a different coefficient in front of x squared, we need to use a different method. So we need to find two numbers whose sum is equal to b, so in this case 13, and whose product is equal to a times c, so in this case 36. So what are those two numbers? In this example, the two numbers would be 9 and 4, because 9 times 4 is indeed equal to 36, and 9 plus 4 is equal to 13. So it fits the two conditions. So what do we now do with those two numbers? We know that it's gonna be 9 and 4, but how do we use them? Well, we can now separate, instead of having 13x, we use the two numbers, so 9 and 4, to divide 13 into two different numbers. Instead of having 13x, I'm going to have 4x plus 9x. So once again, the order doesn't change. You can have 9x plus 4x. It doesn't matter. So now, instead of having 6 times x squared plus 13x plus 6, what you have is 6 times x squared plus 4x plus 9x plus 6. Now you take the two first terms and the two last terms separately. So you have the two first terms and the two last terms. If we try to factorize the terms on the left, we can first factorize by x, and we can also factorize by 2, because 2 times x, if you factorize by 2x, 2x times 3x is indeed equal to 6x squared, and 2x times 2 is indeed equals to 4x. So that's the best you can do in order to factorize the first two terms. Now, if you want to factorize the last two terms, 9x plus 6, the best you can do is factorize by 3, because they're both multiples of 3. So what you end up with is 3 times 3x plus 2. But what you notice now is that we have 3x plus 2. Let me take another color. 3x plus 2 and 3x plus 2. So we can now factorize once again by 3x plus 2. So you factorize by 3x plus 2, and what's left is 2x plus 3. 2x plus 3. So the factorization of 6x squared plus 13x plus 6 is 2x plus 3 times 3x plus 2. And if we try to verify this result, we can expand the expression. 2x times 3x is indeed 6x squared. 2x times 2 is 4x, plus 9x is indeed 13x. And finally, 3 times 2 is indeed 6. So this is how we can verify the result. So this is a bit more tricky, a bit longer, of course, because it's a bit more difficult example, but it's a relatively simple method at the same time, and it's very similar to the one we've seen before. We need to find two numbers who have a certain product and who have a certain sum. It's just that we use different numbers. And then, of course, what's tricky is at the end, just to factorize the two first terms and the two last terms separately, and then factorize the whole equation. Okay, for example, if I want to factorize 3x squared plus 10x minus 8. So the first thing we do is multiply a and c. 3 times minus 8 is minus 24. So we want to find two numbers whose product is equal to minus 24, so the one we found by doing a times c, and whose sum is equal to 10. So the sum of the two needs to be equal to 10, and the product of the two needs to be equal to minus 24. So the two numbers are minus 2 and 12. Why is it minus 2 and 12? Because minus 2 times 12 is equal to minus 24, and minus 2 plus minus 12 plus 12, sorry, is indeed equal to 10. So the product is indeed equal to minus 24, which is what we want, and the sum is indeed equal to 10, which is also what we want. So now what do we do with those two numbers? Instead of writing 10x, I write minus 2x plus 12x. That's the same as what we've done in the previous example. We divide the 10x in two terms, minus 2x and 12x. We now factorize the two separately. So first I factorize 3x squared minus 2x, which factorizes to this, because you just factorize by x times 3x minus 2, essentially. And then I factorize the last two terms, 12x minus 8, I can factorize by 4, which gives me 4 times 3x minus 2. So what I have is, I have x times 3x minus 2 plus 4 times 3x minus 2. I can factorize by 3x minus 2 to give me x plus 4 times 3x minus 2. And if we just verify our results, x times 3x is indeed equal to 3x squared. X times minus 2 plus 4 times 3x is indeed equal to 10x. And finally, 4 times minus 2 is indeed equal to minus 8. So this is the right way of factorizing the expression we had at the start, the quadratic equation. So then, how do we solve a quadratic equation by factorizing it? So if you have a quadratic equation, for example, x squared plus 3x plus 2, we can first factorize it and then solve it. We've seen before that for this example, x squared plus 3x plus 2, we want to find two numbers whose sum is equal to 3 and two numbers whose product is equal to 2. That would be 2 and 1, so it factorizes to x plus 2 and x plus 1. So x squared plus 3x plus 2 is equal to x plus 2 times x plus 1. But this whole thing is equal to 0, because that's from the initial information we have. So if this equals 0, we have two solutions, because if x is equal to minus 2, imagine x is equal to minus 2. This product here, minus 2 plus 2, is simply equal to 0. But if this equals 0, because it's a factorization, because it's a product, if that one is equal to 0, the whole thing is going to be equal to 0. So x is equal to minus 2 is a solution because it cancels out one of the factors. X plus 2 becomes 0, so the whole thing becomes 0, and it is one of the solutions. Similarly, if x is equal to minus 1, x plus 1 becomes 0 because minus 1 plus 1 equals 0, and the whole thing is equal to 0. So this is how you can factorize, solve a quadratic equation by factorizing it, because now you have a product. You can find the two equations. Either one is equal to 0 or the other is equal to 0. So either x plus 2 equals 0, so x is equal to minus 2, or x plus 1 is equal to 0, so x is equal to minus 1. So you can find solutions in this way. So of course, we'll see the quadratic formula, which also solves such equations, but we can also factorize, which is quite a nice way and quite a clean way of solving a quadratic equation. Okay. Okay, can you try to do questions? Yeah, let's say questions 1 and 2 for now. Try to put your answers in the chat for questions 1a and 1b. Try to factorize the quadratic equations. Could I make the question a bit bigger? Yeah, I could. Oops. My bad. Okay, I'm just going to wait a bit more to make sure everyone got the right answers. I got an answer. Okay, I'm just going to zoom in a bit more. Okay, so let's do, so what does the question say? Factorize and solve the following quadratic equations, finding both values of x. So the first step is to factorize. So by factorizing, we can use the methods we've seen before. Here we can see that there's just a factor of 1 in front of the x squared, so we can use the simple method, same here and same here. So first factorizing, and then finding the values of x that solve the equation. So as we've seen in this previous slide. Let me check the chat. Yeah, a lot of answers, really good. Okay. So question 1, factorize and solve the following quadratic equations, finding both values of x. So question 1a. We have x squared plus x minus 56 is equal to 0. If we want to factorize, we need to find two numbers whose sum equals 1. Why 1? Because that's from this number here that just equals 1. And whose product equals minus 56, which is from this value here. So what two numbers add up to 1 and multiply to minus 56? So what are the two numbers? That would be 8 and minus 7. 8 and minus 7. Because then we have 8 times minus 7 is equal to minus 56. And we have 8 plus minus 7 is equal to 1. So those are the two numbers. So when we factorize, we have x squared plus x minus 56 is equal to x plus 8 times x minus 7 is equal to 0. So that's the first step we factorized. Now, which values of x solve this equation? We have x is equal to minus 8 or x is equal to 7. Because if x is equal to minus 8, this becomes 0, so the whole thing becomes 0 and it fits the equation. Or x is equal to 7, if x is equal to 7, this becomes 0, and the whole thing is equal to 0, so it fits our equation as well. So that's for question 1a. Two numbers whose sum is equal to 1 and whose product is equal to minus 56. We find that to be 8 and minus 7. So we factorize x squared plus x minus 56 as x plus 8 times x minus 7. And that equals 0, of course. And so the two solutions are x equals minus 8 or x equals 7. Because one cancels out the first term and the other one cancels out the second term. Okay, question 1b. Oh, I'll take just black pen. Question 1b. So I've got x squared minus 4x plus 4 is equal to 0. Okay, so here sum equals minus 4 and product equals 4. So this is the same thing as before. The sum needs to be equal to minus 4 from here, and the product needs to be equal to 4 from here. So what are the two numbers whose product equals 4 and whose sum is equal to minus 4? That would be minus 2 and minus 2, because then we have minus 2 times minus 2 is equal to 4, and minus 2 plus minus 2 is equal to minus 4. So how do we factorize x squared minus 4x plus 4? This factorizes as x minus 2 times x minus 2. Which we can just, because those are the same exact brackets, x minus 2 and x minus 2, we can just combine them into a power of 2. X minus 2 to the power of 2. And that whole thing is equal to 0. So in that case, there's only one solution. One solution. And it is x is equal to 2. Because if x is equal to 2, x minus 2 goes to 0, so the whole thing goes to 0. And we can also try by plugging in 2 into the initial equation, x squared, so 2 squared minus 8 plus 4 is simply equal to 0, so that also fits the initial equations. Okay, so that was for 1a and 1b. So you can see that sometimes there can be two solutions, minus 8 or 7, but sometimes there can also be only one solution, such as question 1b, where you only found x is equal to 2 as the solution. Okay, question 1c, x squared plus 12x plus 32. Question 1c, x squared plus 12x plus 32. So once again, we have a factor of 1 in front of x squared, so we can just use the basic method. So we have the sum is 12 and product is 32. So the two numbers are 8 and 4, such that the sum 8 plus 4 is equal to 12, and the product 8 times 4 is equal to 32. So x squared plus 12x plus 32 can be factorized as x plus 8 times x plus 4, just from the values we found just here, 8 and 4, so we factorized 8 and 4. And we know that that equals 0. So what are the two solutions? X is equal to minus 8 or x is equal to minus 4. Because minus 8, x is equal to minus 8 would cancel out x plus 8. So would turn the whole thing equal to 0. So that is one of the solutions. And x is equal to minus 4 is the other solution, because if x equals minus 4, x plus 4 becomes 0, and the whole thing is equal to 0. So first step is find the two numbers whose sum is equal to 12 and product is equal to 32. Then we factorize x plus 8 times x plus 4. And because that needs to be equal to 0, either x plus 8 equals 0 or x plus 2 is equal to 0. So either x is equal to minus 8 or x is equal to minus 4. Okay, I hope that makes sense in the reasoning, and I hope I didn't go too fast. It's kind of always the same thing. As you can see, question 1a, 1b, and 1c, at the end of the day, is exactly the same reasoning. Okay, now we go into the second method, which is a bit trickier, where you don't have, you need to factorize and also solve, but you don't have a factor of 1 in front of x squared. It's a factor that's different to 1. In both cases, here we have a factor of 3, for example. Okay, I'll do question 3a now, and then I'll ask you guys to do question 3b. Okay, question 3a. So 3x squared plus 10x minus 8 is equal to 0. So we multiply a and c together. That equals minus 24. So we want to find two numbers whose sum equals 10 and product equals minus 24. So this is just from the theory we've seen in the previous slides, where you multiply a and c together, that equals minus 24. So the two numbers need to have a sum equal to 10. So sum equals 10, that's from here. And a product equals to minus 24, that's from here. So this is actually an example I've used at the start, so we know what the two numbers are. It's minus 2 and 10, because then we have minus 2 times, 12 times 12 is equal to minus 24, which is what we want, and minus 2 plus 12 is equal to 10, which is also what we want. So 3x squared plus 10x becomes minus 2x plus 12x. I use the numbers I just found. And then I can factorize each term separately. So first I factorize this as, I can factorize by x, for example. So x times 3x minus 2. And I can factorize those as well. 12x minus 8, I can factorize by 4. So 4 times 3x minus 2. You notice that we have 3x minus 2 in both terms. So we have 3x minus 2 here and 3x minus 2 here. So we can simply factorize by 3x minus 2. So x plus 4 times 3x minus 2. So from this, we have a factorized version of our initial equation, x plus 4 times 3x minus 2. And that needs to be equal to 0. How do we solve this? How do we find our solutions? Well, either x plus 4 is equal to 0, or 3x minus 2 is equal to 0. Those are the two possibilities. Either x plus 4 is equal to 0, or 3x minus 2 is equal to 0. Because either this one is equal to 0, so the product is equal to 0, or this one is equal to 0, so the whole product is equal to 0. Okay, so x plus 4 is equal to 0. That simply leads, I'll just write them separately. So x plus 4 is equal to 0. That gives us x is equal to minus 4. Or 3x minus 2 is equal to 0, which is 3x is equal to 2. So x is equal to 2/3. So those are the solutions. So we've seen this example before, 3x squared plus 10x plus 8. We multiply 3 and minus 8, we get minus 24. So we want to find two numbers whose sum is equal to 10 and whose product is equal to minus 24. We find those two numbers to be minus 2 and 12, such that minus 2 times 12 is minus 24, and minus 2 plus 12 is equal to 10, which is exactly what we want. We then take our initial equation, 3x squared plus 10x plus minus 8, and we use minus 2 and 12 to kind of separate into two pairs of terms. So we have 3x squared minus 2x plus 12x minus 8. We factorize each one individually. We get x times 3x minus 2 plus 4 times 3x minus 2. We see that we have 3x minus 2 in the two terms, so we can factorize by 3x minus 2, and what's left is is x plus 4. We know that the whole thing needs to be equal to 0, so either x plus 2 is equal to 0, or 3x minus 2 is equal to 0, and that gives us then the solutions. Okay, can you try to do question 3b and put your answers in the chat? So question 3b. In the meantime, I'll just check if there's no. So 3b now. Okay, I'll just wait a bit more. So 3b is actually a lot simpler than what you expect. You can greatly simplify the problem by doing something at the start. If you look at 3, 39, and 126, aren't they all multiples of 3? Can't you simplify by just dividing by 3? Okay, I'll just wait a tiny bit more. Okay, I'll go through the answers now. So 3b, you've got, let me just write actually the question. 3b, you have 3x squared plus 39x plus 126. The whole thing is equal to 0. So when you have such a problem, the first thing to look at and see if you can't simplify the problem. Isn't there a way you can potentially maybe simplify the problem. Instead of straight away, oh, I've got 3x squared, which is different to a factor of 1, so I need to apply the method. No, wait a sec, and just check if you can't simplify anything. So if you try to, in this example, divide by 3 on both sides. Because you see 3 and 39, those are two multiples of 3. So potentially you could divide by 3 on both sides and really simplify the problem. So you have 3 over 3x squared plus 39 over 3x plus 126 over 3 is equal to 0, because 0 over 3 is simply equal to 0. So 3 over 3 is x squared. 39 over 3 is 13, because 13 times 3 is 39. 126 is a multiple of 3. How do we know that it's a multiple of 3? By adding all the terms from 126. 1 plus 2 plus 6 is equal to 9, which is a multiple of 3. So immediately we know that it needs to be a multiple of 3. So 126 divided by 3 is equal to 42. So notice how we greatly simplify the problem. We went from 3x squared plus 39x plus 126 to an expression where you don't have any coefficient in front of x squared. So we can apply the simpler method that we saw at the start. We want two terms whose sum equals 13 and product equals 42. So sum is equal to 13 because we have 13 here, and product is equal to 42 because we've got 42 here. So that's from the method we've seen at the start. That's all because we have a coefficient of 1 in front of x squared. So we can use the simple method. So what are the two numbers whose sum is equal to 13 and product is equal to 42? Those are 7 and 6, because then we have 6 times 7 is equal to 42, and 6 plus 7 is equal to 13. So we can factorize x squared plus 13x plus 42 as x plus 7 times x plus 6. And the whole thing we know is equal to 0. So you see how we really simplify the problem. And now there are two solutions. Either x is equal to minus 7 or x is equal to minus 6. Because minus 7, this one would cancel out x plus 7, which would make the whole thing equal to 0. And x equals minus 6 will make this one equal to 0. So the whole thing would be equal to 0. So 3b, it looks like it's really hard from the start, but it's actually just simplified by dividing by 3, and it's much simpler. Of course, that's all because it's equal to 0. If it had been just the expression, then you can't really divide by 3, and because it would, you still need to take the 3 into account. But here, because it's equal to 0, on the right side, 0 divided by 3 is simply 0, so it doesn't change anything, and then you can really simplify the problem. Okay, so that was for question 3b. So I'll do question 6. Yeah, I'll do question 6 and then look at if you have any questions from the chat that maybe I could go through, and if not, then I can go on with the lesson. Okay, question 6, the triangular prism chocolate box shown below has a volume of 140 centimeters cubed. Determine the only variable length of x. Okay, so here we first need to, so we've got information about the problem. We've got the length of the prism, we've got the height of the prism, and the width of the prism, and we know its volume. So the volume of the prism would be equal to, we have x plus 3 times, so 4 times x plus 3 times 7x, but we need to divide by 2. That's the formula for the volume of a prism. Imagine we have the base, the height, and the length. The volume is equal to base times height times length divided by 2. So that's the formula that you need to know. Okay, so we have this volume, and we know that the volume is equal to 140. So the first thing we could do is multiply by 2 on both sides, such that we have 4 times x plus 3 times 7x is equal to 2 times 140, which is 280. We can now combine 4 times 7x. 4 times 7 is 28. So we have 28x times x plus 3. So all I did here so far is just kind of simplify my my problem. So now what can I do in this case? I've got 28 on the left and 280 on the right. I can divide by 28 on both sides. If I do this, 28 divided by 28 just cancels out, and we're left with x times x plus 3. 280 divided by 28 is simply 10. So we can now expand our expression. So I'm just going to take it here. X times x is x squared, plus 3 times x is 3x, is equal to 10. So all I did is just expand my expression by multiplying within a bracket. Okay, now I just bring the 10 to the left of the equal sign. Minus 10 is equal to 0. So we went from a figure and a couple of distances and information about the problem into a quadratic equation. So that's the first step we need to do. Turn it into a quadratic equation, where we can find the value of x. So we can see in this problem that the coefficient in front of x squared is simply equal to 1. So we can apply the simpler method, where the sum is 3 and product is minus 10. So sum is equal to 3, that's from this term, and product is minus 10, is from this term. That's all because coefficient of x squared is 1. Okay, what are the two numbers whose sum is equal to 3 and the product is equal to minus 10? That would be 5 and minus 2. Because then 5 times minus 2 is equal to minus 10, which is what we want. And 5 plus minus 2 is equal to 3. So we can factorize x squared plus 3x minus 10 is equal to 0. We can factorize it as x minus 10 times, sorry, I had a mistake, x minus 2 times x plus 5. That's from the two numbers I found here, minus 2 and 5, we can factorize. Okay, now that I have factorization, I can either have x is equal to 2 or x is equal to minus 5. However, it needs to be a length. So x plus 3 needs to be positive. But if x is equal to minus 5, x plus 3 is equal to minus 2. So that's a negative length, so that can't be true. So we neglect this solution because it gives a negative length. So the final solution is x is equal to 2. So what did we do in this problem? First, we applied the general equation for the volume of a prism. We know it's base times height times length, the whole thing divided by 2. We know so we just plugged in the values. It's 4 times x plus 3 times 7x divided by 2. And we know that the volume is equal to 140. So that gives us 28 times x plus 3 is equal to 280. We divide by 28 on both sides. We rearrange the equation, and that gives us our quadratic equation, x squared plus 3x minus 10. So if we now solve this this equation, we can find the length of x. So from this quadratic equation, we see that the coefficient of x squared is simply 1, so we can apply the first method we've seen, where the sum of the two numbers needs to be equal to 3, and the product needs to be equal to minus 10. We immediately notice that it's 5 and minus 2, because 5 times minus 2 is minus 10, and 5 plus minus 2 is 3. So x squared plus 3x minus 10 can be factorized as x minus 2 times x plus 5. So the two solutions to the problem are either x plus 2, because if x is equal to 2, we have x minus 2 is equal to 0, so the whole thing equals 0. And if x equals minus 5 plus 5 is equal to 0, so the whole product is equal to 0. However, x is equal to minus 5 is not a variable length, because then x plus 3 would be negative. So the only solution would be x is equal to 2. So our prism has a base of 5 centimeters, a height of 4 centimeters, and a length of 14 centimeters. Okay, I hope that was clear in the reasoning and on how we applied the knowledge we've seen so far. Okay, before going into quadratic formula, let me just check if there's no questions in the chat. Okay, people are asking about how do we solve an equation system with 3 equations and 3 variables. That's something you'll see in maybe not next year, even the year afterwards. And it's using elimination and how to combine the different lines to solve the problem. But that's not for now, not yet. So there seems to be many questions about question 2a. So let me maybe, okay, just wait a second. I don't have question 2a in my presentation, but I'll take it from okay, I'll do 2a and 2b with you guys. Okay, so that kind of problem is really really kind of always the same thing. It's always repeating the same reasoning and repeating the same methods. So that's why the more you do, the better you get at it. So it's really practice, practice, practice. Okay, question 2, there seem to be a lot of problem with. And just make sure there's no other question. So we won't be doing quadratic simultaneous equations. That's not for now. I've specifically been told not to do quadratic simultaneous equations, but maybe in the future, maybe next year. Okay, and 2. So we have x squared plus 5x is equal to 6. first thing we do is we bring the 6 to the left side. So x minus 6 is equal to 0. So we see that we have a coefficient of 1 in front of the x squared, so we can just apply the basic method, where the sum is 5 and product is minus 6. So can we find wait a second. Can we find two numbers whose sum would be equal to 5 and whose product would be equal to minus 6? So let's check. Sum is equal to 5 and product will be minus 6. That's a good question, actually. So the sum is equal to 5 and product is minus 6. Oh, wait a second. There was just a problem with my... Wait. Do you see my screen? No, I don't think you do. Oh, that's annoying when that happens. Wait a sec. Sorry for that little. There we go. Okay. So the sum would be equal to 5 and the product would be equal to minus 6. So two numbers whose sum is equal to 5 and product is minus 6 would be, for example, 6 and minus 1. Because then we have 6 plus minus 1 is equal to 5, and 6 times minus 1 is equal to minus 6, which is exactly what we want. So if we can factorize x squared plus 5x minus 6, we can factorize it as x plus 6 times x minus 1. And we know that the whole thing is equal to 0. So that's using 6 and minus 1. We can factorize as x plus 6 times x minus 1. Okay, so then the two solutions are either x plus 6 is equal to 0 or x minus 1 is equal to 0. So the two solutions are x is equal to minus 6 or x is equal to 1. And if we check in the initial equation, if you plug in the value 1, we would have 1 squared plus 5 times 1, which is indeed equal to 6. If you plug in the value minus 6, squared plus 5 times minus 6 would have 36 minus 30, which is indeed equal to 6. So that's just a way of verifying our result at the end. Okay, now let's try question 2b. X squared minus 3x is equal to 40. So if we just rearrange it, we have x squared minus 3x minus 40 is equal to 0. So we have a coefficient of 1 in front of the x squared, so we can simply apply the basic method, where the sum is minus 3 and the product is minus 40. So what are two numbers whose sum would be equal to minus 3 and whose product would be equals to minus 40? That could be, for example, minus 8 and 5. Then we have minus 8
times 5 is equal to minus 40. And we have minus 8 plus 5 is equal to minus 3. So we can factorize x squared minus 3x minus 40 as x minus 8 times x plus 5. And we know that the whole thing needs to be equal to 0. So either x minus 8 equals 0 or x plus 5 equals 0. So either x is equal to 8 or x is equal to a minus 5. So how did we factorize? It's basically the same way as before. We found the two numbers whose sum is equal to minus 3 and the product minus 40. We can then factorize using minus 8 and 5. Okay. Let me check the questions. Did I make a mistake somewhere? Oh, no. Right. Okay, sorry, I can't see the chat at the same time as doing questions. Okay, question 2C. So we don't have much time before the lunch break. So 2 more questions, and we'll have the small lunch break. Well, small, 1 hour. 4. Let's do 2C. We have 3D and then lunch break. Okay, so let's do those two. So we just bring the 6x to the left. So x squared plus 5 is equal to 6. We bring the 6x to the left. 6x is equal to, plus 5, which is 0. Sorry, sum and product equals 5. Yeah, okay, yeah, that's the right thing. So because then we have minus 5 plus minus 1 is equal to minus 6, which is exactly what we want. So we can factorize x minus 5 times x minus 1, the whole thing being equal to 0. So how did we factorize? Just like before, we factorize this based on the two numbers whose sum equals minus 6 and product equals 5. So then the two solutions are either x minus 5 is equal to 0 or
to do at the start is bring the 6x to the left. So it's basically by subtracting by 6x to the left and to the right of the equal sign. And then it's the same method as before. Okay. Question 3D is a bit trickier. I mean, it's not really harder than the ones we've seen before, because all you need to do is really rearrange the equation. So x squared plus 10x plus 56 is equal to 7x squared plus 67. All you need to do is bring the 7x squared to the left and the 67 to the left. So 8x squared minus 7x squared, you would have x squared plus 10x plus 56 minus 67, that would be minus 11. So what I did here is I subtracted by 7x squared plus 67 on both sides. And by subtracting, 8x squared became x squared and 56 became minus 11. So now we see that we have a coefficient of x squared is 1. So we can apply just the simple method, where the sum of the two terms needs to be equal to equals 10, and product equals minus 11. That's simply from here, 10, the sum needs to be, and the product needs to be equal to minus 11. So that minus 11 and 1, because then the product of the two, minus 11 times 1, is minus 11. 11. Oh, sorry, it's 11 and, because then 11 times minus 1 is minus 11, and the sum 11 plus minus 1 is simply 10. So that fits our conditions. So we can then factorize x squared plus 10x minus 11 as x plus 11 times x minus 1. And we know that this equals 0. So just like before, either x plus 11 equals 0 or x minus 1 equals 0. So that means that either x equals minus 11 or equal to 1. Don't subtract by 7x squared plus 67 on both sides. You see that at the end, you only get a coefficient of 1 in front of x squared, so that's good because you can use the basic method. You just rearrange slowly, x squared plus 10x minus 11. The sum of two terms needs to be equal to 10, and the product of the two needs to be equal to minus 11. So you find the two terms being 11 and minus 1, because then you see that 11 times minus 1, the product is equal to minus 11, and the sum is indeed equal to 10. Using those two numbers, so using 11 and minus 1, you can simply factorize the expression x squared plus 10x minus 11 is equal to x plus 11 times x minus 1. And then either x plus 11 is equal to 0 or x minus 1 is equal to 0. So you find your values for x. Okay, I hope this was clear. Okay, so I don't see any more questions in the chat. Don't hesitate to use the chat during the lunch break if you have any something you haven't understood in the lesson so far. So it's now half 12. Let me check. Yeah, half 12. So we can have now our little lunch break. Don't hesitate to use the link I sent in the chat to give me some feedback about my lessons. If there's something you liked, something you didn't like. Something you struggled with. with. Do you hear me? It just says I lost my connection, but I don't know if that. Okay, I hope I didn't lose my connection. So either way, it doesn't really change because we have our lunch break now.
Okay, sorry for the small issue. I mean, it's the lunch break now, but I just had a Wi-Fi issue. I hope it didn't affect the lesson too much. Okay, so it started around 12:22. Okay, sorry about this. I hope I won't have any issue in the second part of the lesson. So now is the lunch break, and maybe I could go through the questions where it lagged again at the start of the second part of the lesson. Sorry for the small issue. Obviously, I couldn't see the chat, so if I could have seen the chat, I would have done something for it. Okay, so lunch break is until 1:30, so I'll see you then, and I'll try to fix my Wi-Fi as well, as best as possible. So now lunch break until 1:30. Don't hesitate to use the link in the chat to send your feedback. Sorry again for the small Wi-Fi issue. I really couldn't see anything wrong. Okay, I'll see you at 1:30. Have a good lunch, everyone. Okay, welcome back everyone. Hopefully it doesn't, it works fine this time. There's no issues. I just wait one more minute, make sure everyone's back in the lesson, because now I can see how many people are attending the call. So I'm just going to wait a bit to make sure there's a high enough number. Okay, so just for the second part of this lesson. So first of all, I'll be going through the questions that you missed because of the Wi-Fi issues. So that was question 2b, question 2c, and question 3d. So for the factorizing part of the lesson, and then we'll be going through the quadratic formula and see how do we use that formula in exercises, and then do some past paper problems. Okay, let me share my screen. Okay, can you just say in the chat if you can hear me well and see the PowerPoint? Just to make sure there's no issues this time. So remember, there's a 30-second delay between when I talk and when you hear me talking, so that's why I might be it might seem like I'm delayed. Yeah, okay. Perfect then. So let's get back to question 2b before I started lagging before the lunch break. So we did question 2a. I think that you guys heard the reasoning for question 2a. Well, question 2b is basically the same thing. So we've got x squared minus 3x is equal to 40. The first step, obviously, is to bring the 40 to the left side of the equal sign. So you do minus 40 on both sides of the equal sign, and that gives you x squared minus 3x minus 40 is equal to 0. So because you've got a coefficient of 1 in front of the x squared, you know that you can use the basic method. The method we've seen at the start, where you just take minus 3 and minus 40 and define those two as 1 being the sum of two numbers and the other one being the product of two numbers. So the sum of the two numbers needs to be minus 3 and the product of the two numbers needs to be minus 40. The two numbers that satisfy this condition are minus 8 and 5, because minus 8 times 5 is minus 40, and minus 8 plus 5 is minus 3. So careful that, for example, 8 and minus 5 would not work, because you'd get, 8 times minus 5 would give you minus 40, but 8 plus minus 5 would give you 3 instead of minus 3. So you need to make sure that the right number has the right sign. So that's why here we have minus 8 and 5. Okay, so x squared minus 3x minus 40, you can factorize as x minus 8 times x plus 5, because minus 8 and 5 were the two numbers you found. It's essentially same as when we saw the method at the start, is the a and b. So x plus a times x plus b becomes x minus 8 times x plus 5. We know that that equals 0, so there are two possibilities. Either x plus 8 is equal to 0, or x plus 5 is equal to 0. So if x minus 8 is equal to 0, that means that x is equal to 8. If x plus 5 is equal to 0, that means x is equal to minus 5. So that means that we find two solutions to this problem. Either x is equal to 8 or x is equal to minus 5. So this is how we solve such equations using by factorizing the expression. So for question 2c,
So the first thing every time is to rearrange the expression such that you get a times x squared plus b times x plus c is equal to 0. So here I had x on the right-hand side of the equal sign. So all I need to do is subtract by minus 6x on both sides of the equal sign. So on the right-hand side, it just cancels out and gives 0. And on the left-hand side, it gives you x squared minus 6x plus 5. So same here, the coefficient is simply equal to 1. So we can just apply the basic method we've seen at the start, where the sum of two numbers needs to be equal to minus 6, and the product needs to be equal to 5. So minus 6 comes from here, and 5 comes from here. So what are the two numbers whose sum equal minus 6 and whose product equals 5? That would be minus 5 and minus 1, because minus 5 times minus 1 simply gives 5, and minus 5 plus minus 1 is minus 6. So both conditions are satisfied, and the sum is indeed equal to minus 6, and the product is indeed equal to 5. So that means that you can now factorize your expression. X squared minus 6x plus 5 can be factorized into x minus 5 times x minus 1. And that, of course, equals to 0 from the start, from the what we had at the start of the problem. So the solutions to this equation is either x minus 5 is equal to 0 or x minus 1 is equal to 0. In both cases, if one of them is equal to 0, the whole product will equal 0, because whatever you multiply by 0 will be equal to 0. So x minus 5 equals 0, that would mean x is equal to 5, and x minus 1 equals 0, that would mean x equals 1. So these are the two solutions to your quadratic equation. So that was for question 2C. For question 3D, it looks like it might be quite a complicated problem when you see this the question at the start. You have 8x squared plus 10x plus 56 is equal to 7x squared plus 67. But that's just an annoying way of writing it. At the end of the day, all you need to do is put the terms together. So all the x squared you put together, all the x's you put together, and all the constants you put together. So on the right hand side, I want to have equal 0 because that's the best way of solving the equation. So I subtract by 7x squared plus 67 on both sides. So on the right hand side, it just cancels out, you get 0. And on the left hand side, you have 8x squared minus 7x squared, which gives you just x squared. You have plus 10x, and 56 minus 67 is equal to minus 11. So now you have the right form for the expression. You've got ax squared plus bx plus c is equal to 0. And you see that here the coefficient of x squared is simply equal to 1. So you can see that from a problem that looks quite hard, you've got a problem where you just need to use the basic method that we've seen at the start. So we need to find two numbers whose sum equals 10 and whose product equals minus 11. So those two numbers would be 11 and minus 1, because 11 times minus 1 is minus 11, and 11 plus minus 1 is 10. So those two numbers fit the two conditions. So x squared plus 10x minus 11 can be factorized as x plus 11 times x minus 1. That's from the two numbers we found previously by looking at the sum and the product. And of course, that equals 0. So in order to find the solutions, we know that either x plus 11 is equal to 0 or x minus 1 is equal to 0. So the two solutions would be x is equal to minus 11 or x is equal to 1. And those are the two solutions to your quadratic equation. Okay, I hope that makes sense, and that the Wi-Fi issue that were present before the lunch break didn't affect the lesson too much. Just quickly chat to make sure that there's no questions. Okay, there doesn't seem to be any questions. Okay. So if you want me to go through any other questions I haven't done, because of course I don't have time to go through all the questions, that's something I can do at the end of the lesson. So we finish the quadratic formula, and I can then go through questions I haven't done. So the main thing now is to finish all the theory, finish the last part, which is the quadratic formula, which shouldn't take too long, like half an hour, 45 minutes. And then at the end, I can go through questions that I haven't done because, yeah. Okay, so let's go through the last section of this lesson, which is on the quadratic formula. So quadratic formula is just another way of solving a quadratic equation. So when you had a quadratic equation before, as we've seen in the examples before, we used a method where we factorized and then found the solutions based on the factorization. However, you can also use a formula where you don't require any factorization. All you need is the initial expression for the quadratic equation, and based on that expression, you can just plug in the values into the formula and get the solutions. So it's a very, very useful formula, and that is used all the time, in maths at least, because quadratic expressions are expressions that you encounter very, very often. We have x squared, that would be a quadratic equation, and it is quite often that you encounter such expressions. And also based on the results you get using the quadratic formula, you can also find a way to factorize your expression. So that's something we'll see as well in this last chapter. Okay, so the solution for quadratic equation ax squared plus bx plus c is equal to 0 is this equation. So x is equal to minus b plus or minus square root of b squared minus 4ac, the whole thing divided by 2a. So as you can see, the plus or minus shows that there are two solutions. So the first solution will be with the plus sign, and the second solution will be with the minus sign, or vice versa. And as we'll see in the next few slides, those solutions are where the function crosses the x-axis. Because when you think about a function, if you think about a function, y is equal to ax squared plus bx plus c. If we try to find ax squared plus bx plus c is equal to 0. That's the same thing as y is equal to 0. So we're trying to find the x value where y is equal to 0. But where is y equal to 0? That's when the function crosses the x-axis. So when we try to find ax squared plus bx plus c is equal to 0, essentially what we're trying to do is find the x value where the function ax squared plus bx plus c crosses the x-axis. And with a quadratic equation, there are three outcomes you could have. You could either have no solutions. So what would no solutions mean? That means that the function does not cross the x-axis. You could have one solution where the function just barely touches the x-axis in one point, or you could have two solutions where the parabola crosses the x-axis in 2 points. And that's the quite a common case. We have the plus or minus, so you have two solutions. So this is another example where, of course, you can use the formula to find the solutions to your equation, but just looking at the function graphically, you can find the solution by looking at when
the function crosses the x-axis. Because trying to find ax squared plus bx plus c is equal to 0 is the same thing as analyzing when y is equal to 0, so when the function crosses the x-axis. Okay, so if we use an example, solve using the quadratic formula, 2x squared minus 5x minus 6 is equal to 0. So in this case, we need to find a, b, and c. So a would be 2. B would be, here you need to be careful and use minus 5 because you've got a minus sign. And C, you guessed it, is minus 6 because you also have a minus sign. So you always need to make sure it has the right form. You have ax squared plus bx plus c is equal to 0. So it needs to be equal to 0, otherwise the equation doesn't hold. So what do you do with that information? You know a, b, and c. Well, now all you need to do is plug in the values. You know that the solution is ax is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So that's an equation you'll remember quite easily because you'll use it all the time. So it's the quadratic formula. That's very useful. So I plug in the value for b, I plug in the value for a, and the value for c. So I have a minus 5, which is just 5, minus 5 to the power of 2, plus plus 24 times 2, 48. So that gives me 73 inside the square root. And the denominator is equal to 2 times 2, which is 4. So the two solutions would be 5 minus square root of 73 over 4 and 5 plus square root of 73 over 4. So as you can see, using that formula, you notice that most often you won't have a very simple result. You won't just have x1 is equal to minus 1 and x2 is equal to 4. It's most of the time it will be values that don't just land on the whole number. They can be quite difficult to calculate, and that's something you can see from the equation itself. It has it's first a fraction and it has square root, so there are many ways that it can be quite a difficult result. So by using the quadratic formula, we find that the solution to 2x squared minus 5x minus 6 is equal to 0 are x1, the first solution is minus 0.89, and the second solution is 3.39. So we call those solutions the roots. If you imagine a function that has two solutions, so imagine a parabola, and you have two solutions, x1 and x2. Those solutions are when y is equal to 0. Remember, this is the y-axis, this is the x-axis, so when y is equal to 0, that's when the function crosses the x-axis. And x1 and x2 are called the roots of the function. So the two roots of the functions are when the function crosses the x-axis. So the solutions that you find using the quadratic formula are actually the roots of your function. So once again, using GeoGebra, I plotted the function y is equal to 2x squared minus 2x squared minus 5x minus 6. So this is the function you see here. So what you notice, here you find x1, and here you find x2, where x1 was approximately equal to minus 0.89, and x2 was approximately equal to 3.39. So you notice that indeed, looking at the function graphically, you find those two roots that are approximately equal to minus 0.9 and 3.4. So you can find the roots of a function graphically by just looking at when it crosses the x-axis. So obviously, it's not always the case that it crosses the x-axis. You might have a function that goes like this, and here, as you can see, it never crosses the x-axis. You could have a function that goes like this, where it just barely touches at one point. So you could either have one solution, two solutions, or no solutions. But here is a good way to, if you calculate using the quadratic formula, you find two roots to your function. You can type in the function into a plotting software such as GeoGebra, and you can actually verify your answer by looking at where the function crosses the x-axis. So that's also a good way of verifying your results. It's always really good to link the algebra of a problem to the graphical representation of that problem. Same as before, we had simultaneous equations, where we had two equations with two unknowns. Well, it might sound really difficult. You have x and y's and quite a long calculation to find solutions. But at the end of the day, it's just the intersection between two straight lines. Seen here, you might look at this equation and be like, whoa, that's a difficult one. But at the end of the day, it's just when the function crosses the x-axis. So it's always good to have that link between the algebra and the graphical representation. Okay, I hope that makes sense. Okay, if we look at the expression that we use to find the solutions for a quadratic equation. So if you remember, this is when ax squared plus bx plus c is equal to 0. Okay, if we look at this expression, there are quite a few things that we can't have. So the first thing that we can't have is a needs to be different to 0. As you can see here, you can't divide by 0, so a needs to be different to 0. And that makes sense. Why does it make sense that a needs to be different to 0? Because if a was equal to 0, this equation would not apply, because if a equals 0, your term would just disappear, and you would not have a quadratic equation, you would just have a linear equation. So this expression shows that, first of all, it needs to be a quadratic equation where a is different to 0. Okay, that's the first thing. Now, if we look at the square root, what's a condition for a square root? If we have square root of x, we know that x needs to be bigger or equal than 0. If x is negative, then we don't have any solution, because x, the square root of a negative number, does not exist. Well, it does, but that's when you go into imaginary numbers, and that's something you do in year 13. But here, when we consider real solutions, the square root of a negative number does not exist. So here, b squared minus 4ac needs to be bigger or equal than 0. So what happens if b squared minus 4ac is negative? Well, if whatever is inside the square root is negative, we don't have any solutions. So how do you check if your function crosses the x-axis or not? You calculate b squared minus 4ac, and if it is negative, then you immediately know that your function does not cross the x-axis. So if b squared minus 4ac is negative, then function does not cross x-axis. Now, what if b squared minus 4ac is equal to 0? Well, if b squared minus 4ac is equal to 0, so if b squared minus 4ac equals 0, our equation becomes x is equal to minus b plus or minus square root of 0 divided by 2a. But plus or minus square root of 0, that's just equal to 0. So the solution would just be minus b over 2a. And the plus or minus doesn't play a role anymore because it's plus or minus 0. It's regardless of if it's plus or a minus 0, it doesn't change anything. So if the square root equals 0, so if b squared minus 4ac is equal to 0, we only have one solution. Sorry. So this sorry. This equation b squared minus 4ac is actually very useful because if it's positive, there are two solutions. If it's equal to 0, there's only one solution. And if it's negative, we don't have any solutions. So you can see that just looking at the equation, we already have quite a good understanding of how the solutions are going to work and how b squared minus 4ac is a very important part of the solution because it determines how many solutions there will be. Okay, so that's just looking at the equation and analyzing what potential solutions we could have. So here's an example. Okay, so first we have x squared plus 2x plus 1 is equal to 0. There is one solution, and that is x is equal to minus 1. That's because we can factorize this expression as x plus 1 squared is equal to 0. Now, if we look at b squared minus ac, so if you calculate b squared minus 4ac, so b is equal to 2, so 2 squared, minus 4 times a is equal to 1, and c is equal to 1. 2 times 2 is 4, 4 minus 4 is equal to 0. So that shows that b squared minus 4ac in this case equals 0, and it shows that there's only one solution. And as you can see here, the only one solution is x is equal to minus 1. That's the only point where the function crosses the x-axis. Well, it doesn't cross the x-axis, it touches the x-axis, but you get what I mean. Now, if we look at another example, x squared plus x plus 1. Okay, so let's calculate the b squared minus 4ac of this equation, b squared minus 4ac. b is equal to 1, so we have 1 squared minus 4 times 1 times 1, and that's equal to minus 3. So that shows that you already know that there won't be any solutions because b squared minus 4ac is negative, so the square root will have a negative value inside of it, and that cannot exist, so you don't have any solutions to the equation x squared plus x plus 1 is equal to 0. And that's something you can see from this graph. It doesn't cross at any point the x-axis. It's always above the x-axis, it never crosses it. So that's how you can see that it doesn't have any solutions. I could have added another example. We have two solutions, but that's quite a common one, so I didn't in this case. Okay. I think I've done everything on this slide. Yeah. So, summary of how, by looking at the expression of a quadratic equation,
how we can determine if there are 1, 2, or no solutions. So if whatever is inside the square root is positive, we have 2 solutions. And that's because we have this plus or minus sign. So we either have plus the value or minus the value. And because b squared minus 4ac is bigger than 0 but not equal to 0, the plus or minus does play a big role, so there are 2 solutions. Now, if b squared minus 4ac is equal to 0, then we have 1 solution. Because the square root equals 0, so the plus or minus sign doesn't change anything. Indeed, if you have b squared minus 4ac is equal to 0, that means that the square root is equal to 0, and that simplifies as minus b over 2a. That's only 1 solution. So in this case, b squared minus 4ac is equal to 0, you know that you'll only have 1 solution. Now, the last possibility is if b squared minus 4ac is negative. Now, if b squared minus 4ac is negative, we have no solutions. That's because you can't have something negative inside the square root. And so, because a solution doesn't exist to a negative value inside the square root, you know that a solution to your equation won't exist. That's because your function does not cross the x-axis. So if we summarize using the x-axis as well, in this case you have 2 roots. Here you have 1 root, and here you have no roots. That makes sense because 2 solutions means 2 roots, 1 solution means 1 root, no solutions means no root. Because as I said before, a solution is a point where the function crosses the x-axis, which is defined as a root of the function. Okay, I hope that makes sense so far. If we look at some examples, use the quadratic formula to solve the following quadratic equations. Give all answers to 2 decimal places. You must show you're working. Okay, so x squared plus x minus 10 is equal to 0. Let's do that one first. So for a 1x squared plus 1x minus 10 is equal to 0. So here we have a equals 1, b equals 1, and c equals minus 10. So if we simply apply our equation, we have x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. We plug in the values, we have minus 1 plus or minus square root of b squared is 1 squared minus 4 times 1 times minus 10. The whole thing divided by 2 times 1, which is 2. So you have 2 solutions, minus 1 plus or minus 1 times 1 is 1, plus 40 is square root of 41 divided by 2. So your 2 solutions are either x1 is minus 1 minus square root of 41 divided by 2, and x2 equals minus 1 plus square root of 41 divided by 2. Okay, I don't have the actual value. Let me quickly check. The answers to this one, just to make sure. Question 4a. Okay.
share my screen again. So the two answers are minus 3.7 and 2.7. So if we round to two decimal places, that will be approximately equal to minus 3.70 and 2.70. Okay, what I could do is show you what this graph looks like on GeoGebra. Just give me a sec to start. There we go. So if I show you my screen. So what was the expression x squared plus x minus 10? So x squared plus x minus 10. There we go. So as you can see from looking at this function, you immediately notice that there are two solutions. The function crosses the x-axis in 2 points. So the first point is about minus 3.70. So as we wrote, we rounded to two decimal places, and the other root would be at x is equal to 2.70. So that's always good. You do your calculation and then you verify by using visualizing graphically what your function looks like, and make sure that it does indeed have two solutions, and that you have the right solutions as well, of course. Okay, let me now. Oh, people say that they use Desmos as well. I use GeoGebra. I'm sure Desmos is good as well, but I've never actually used it. Okay, let's do the second one. Question 4b. 5x squared plus 3x minus 22. So in this example, we have a is equal to 5, b is equal to 3, and c is equal to minus 22. So we just use our equation, minus b plus or minus square root of b squared minus 4ac, the whole thing divided by 2a. So minus b would be minus 3 plus or minus 3 squared minus 4 times 5 times minus 22. The whole thing divided by 2a. 2 times 5 is 10. Now we can simplify what's inside the square root. 9 minus 4 times 5 times 22. Let me just make sure I have the right answer for this one. 4 times 5 times 22 plus 9. 449. Okay, 449. So you have two solutions as well, because the value inside the square root is positive. Let me just verify that I have, just look at the answers, minus 2.42 and 1.82. So x1 minus 2.42 and x2 is equal to 1.82. That's by doing first the minus sign, so minus 3 minus square root of 449 divided by 10, and then the plus sign, minus 3 plus square root of 449 divided by 10. So once again, if I share my screen to show you what it looks like on a graph. So what is the question again? 5x squared. There we go. You can see that indeed there are two solutions. My function here, 5x squared plus 3x minus 22 crosses the x-axis in 2 points. So you have this first point to the left, where the root, here it's written racine, which means root, is minus 2.42 if I round to 2 decimal places. And my second root is my 1.818, which if I round to 2 decimal places would be 1.82. So once again, we used the quadratic formula and got the right results by looking at a graphical representation of our function. Because once again, the roots are found when our function 5x squared plus 3x minus 22 equals 0. So when the function crosses the x-axis. Okay, that's good. Let me share my PowerPoint again. So this chapter on quadratic formula is quite an easy one because it's always, unlike when we use when we factorize or when we solve the simultaneous equations, we had different methods depending on which one was easier or which one or in which situation we were. But in this case, it's literally always the same thing because you have your formula, ax squared plus bx plus c is equal to 0. All you need to do is plug in the values into the equation, and that's it. You just plug in the values, find the two solutions, and you're good to go. So that's why this chapter is relatively easy, and it's not too much trouble with this one. Okay, solve for x using the quadratic formula. So you have 3x squared minus 42x plus 147 is equal to 0. So once again, it's exactly the same thing. So you have a is equal to 3, b is equal to minus 42, and c is equal to 147. So you'd simply plug in the values into your equation. Minus b plus or minus square root of b squared minus 40c divided by 2a. So b is 42, so minus 42 is 42, plus or minus square root of minus 42 squared minus 4 times 3 times 147 divided by 2 times a, which is 6. So you have 42 plus or minus, let me just use my calculator once again, 42 times 42 minus 4 times 3 times 147. Let me just 2 seconds. And what you found, wait, there we go. What you find out is 42 times 42 is 1,764, and 4 times 3 times 147 is actually 1,764 as well, divided by 6. So 1,764 minus 1,764, that just cancels out. So your square root is equal to 0. So you've got 42 plus or minus 0 divided by 6, which is basically 42 divided by 6, which is 7. So in this case, that's an interesting one because you have you simply have one solution because your square root was equal to 0. So that means that for x is equal to 7, 3x squared minus 42x plus 147 is equal to 0. But now, what if we factorize this expression? What if we try to factorize using this solution? So I'm just going to put it here. So we know that if x equals 7, our function equals 0. So that means that potentially x minus 7 squared could be our function, because we know that it's a quadratic equation, because it has x to the power of 2. So it's a second order polynomial equation. And it's the only solution, so it needs to be to the power of 2. However, that would give us a coefficient for x squared that is simply equal to 1. So what we could do is simply multiply this by 3. So let's check if this actually works. What happens if we try to do this? So 3 times x squared minus 14x plus 49. Now we multiply by 3, 3x squared minus 42x plus 49 multiplied by 3 is 147. So as you can see, using our quadratic formula, we found, so this wasn't part of the exercise, but it's always good to realize, we found a value for the root of our function. Because we found a root of our function, we can use that root to factorize our equation. So it needs to be, when x is equal to 7, we know that the whole function equals 0. So potentially we could factorize as x minus 7 to the power of 2. However, we know that we have a coefficient of 3 in front of the x squared instead of a coefficient of 1. So what I simply did is multiply the whole thing by 3, and we indeed get the right result. So that's how you can proceed with this. Let me do something else. Yeah, I'm just going to add another example using exactly this. If we think of, I just need to share my screen again. If you think of another example that I just invented, let's say x squared plus 9x plus 20. Okay, x squared plus 9x plus 20 equals 0. So using a quadratic formula, this should be minus b plus or minus square root of b squared minus 4ac divided by 2a. So b is equal to 9 in this case, so we have minus 9 plus or minus square root of b squared. So we have b is 9, 9 squared is 81, minus 4 times 1 times 20 divided by 2, because 2 times 1 is 2. So we have minus 9 plus or minus 81 minus 80 is simply 1 divided by 2. So the two solutions are x1 is equal to minus 9 minus 1 divided by 2, which is minus 5, and x2 is equal to minus 9 plus 1 divided by 2, which is minus 4. Okay, so we have two solutions. We have two values where our function equals 0. So could we factorize using those two values? because we know that if x is equal to -5, it equals 0. So that means that we could factorize by x plus 5. And we could factorize by x plus 4. Because if x is equal to -5, the whole thing equals 0, or if x is equal to -4, the whole thing equals 0. So let's verify if this works. If we now expand x times x, x times 4, 5 times x, 5 times 4. We have x squared plus 4x plus 5x plus 20. As you can see, it brings the same, gives the same equation. So from the solutions you get from the quadratic equation, you can also factorize your expression. Now, of course, if instead of being x squared plus 9x plus 20, imagine it had been twice that. Imagine it had been 2x squared plus 18x plus 40. Then in that case, the coefficient of x squared was 2 instead of 1. So you would need to multiply the whole thing by 2, such that you get 2x squared plus 18x plus 40. Of course, that's not the case here. We just use a factor of a coefficient of 1. But just so you know that when the coefficient is different to 1, you need to multiply by the coefficient in order to factorize correctly. Okay, if we do an example similar to this one, or we could do a Microsoft quiz. Yeah, I might just pose a Microsoft quiz, and if you have any questions, I can look in the chat and answer them. So we now have the second Microsoft quiz on quadratic formula, but also factorizing. So Microsoft quiz. So people are asking about the answers to all the exercise sheets. So that will be given to you after the lesson, I think. It should be sent to you by email, so you can check, because obviously I don't have time to go through all the questions, but it will be sent to you by email. For question 7, why is 42 outside the root positive and not negative? Okay, question 7. Okay, yeah, so b was equal to minus 42, but in our equation we have x is equal to minus b. So minus b, that would be minus 42. So minus 42, the minus signs cancel out, and we're just left with 42. So that's why it's positive instead of negative, because we have minus b, and b was equal to minus 42. Okay, I'm just going to give you a bit more time for the Microsoft quiz. Don't hesitate to put questions in the chat, because obviously sorry, I'm losing my words. These topics are quite repetitive. It's always applying the same topic over and over again. So it's I could go through thousands of questions, but it would be really always the same thing. So I try to vary this much, to vary
content as much as possible, but obviously it's hard when it's such a redundant topic. So just answer the Microsoft form for now and send questions in the chat if you have any. Okay, I'm just going to give you a bit more time. Only 35 answers so far, with 130 people on the call, so just waiting a bit more to get a bigger portion of the class. Don't worry, it's anonymous, of course. I can't see who answered what. But it's always a good test to see how well you do on a little quiz. Just going to wait 1 more minute. Oh, I might have made a mistake here. Yeah, I made a mistake. Yeah, so question 4, don't worry if you got it wrong, because I got the answers wrong. I did the mistake that I said not to do, which is to get the wrong sign, so plus sign instead of a minus sign, or a minus sign instead of a plus sign. So question 4, I put my answer. My answer is wrong, so don't pay too much attention to your score. The main thing is to I'm going to correct it correctly now.
Yeah. So as I said, question 4, I got the wrong answer. But for those of you that got -4 and 3, that is indeed the right answer. Okay, I'll go through the questions now. Let me share my screen. Sorry again, I made there's always 1 or 2 small mistakes like this. I hope it doesn't bother you too much. Okay, so this quiz was on quadratic formula, but also on factorizing quadratic expressions. So as you can see, there's a graph and there's a question. So we here have the function y is equal to x squared plus 2x plus 1. How many roots does the function have? So roots, as I said, is solutions to y is equal to 0. 2, x equals -1 and y is equal to 1. 1, x is equal to -1, none, or another answer. So what are roots? It's when y is equal to 0. So when the function crosses the x-axis. Where does this function cross the x-axis? Just at one point. Here. X is equal to -1. So how many roots does it have? 1. It's when x is equal to -1. Y is equal to 1 is not a root. That's where the function crosses the y-axis. But here we're talking about the x-axis. So the answer was 1 when x is equal to -1. Just check the answers. Yeah, most of you got the right answer. So even if it doesn't cross, as in have an intersection, it touches the x-axis, so that would be the root. Factorize x squared plus 2x plus 1. So by factorizing, we do what we do all the time. Here we have a coefficient of 1 in front of x squared, so we can just use the basic method. The sum needs to be equal to 2 and the product needs to be equal to 1. That's the answer would be simply 1 and 1. So you can factorize by doing x plus 1 times x plus 1. That would be x plus 1 squared. So that would be the answer. Now, look at your answer to 2 and your answer to 1. Do they agree? So your answer to question 1 was that there is one root. It's when x is equal to -1. Now, in question 2, we tried to factorize this equation and we got x plus 1 squared. They both agree, of course, because when x is equal to -1, that's when the whole function equals 0, because -1 plus 1 squared is equal to 0. And as we said here, there's only one solution, because x plus 1 squared, there's only one solution. It's when x is equal to -1. You could also use the quadratic formula by doing b squared minus 4ac. Here we have 2 times 2, 4 minus 4 is 0. So we can see that there's only one solution because b squared minus 4ac equals 0. So do they agree? Yes, they do agree. So question 2, most of you got this answer as well. And then, wow, all of you got, got the right answer to this one. Question 4, that's when I got it wrong. Solve the equation and write your answer as xxs and xxs. For example, my student one. X squared plus x is equal to 12. So there are many ways you could solve this. You can factorize, you can use a quadratic formula, or you can guess, because it's a relatively easy one. You can also take a guess. So if you use the quadratic formula or if you factorize, the best thing to do first is to bring the 12 to the left side, which would give you x squared plus x minus 12 is equal to 0. If you try to factorize, you need to find two numbers that add up to 1 and then multiply to 12. That would be, for example, 4 and minus 3, which would give you solutions of minus 4 and 3. You can also use the quadratic formula by just plugging in the values, and you find an answer of 3 and minus 4. So here, as you can see, I wrote minus 3 and 4. This is wrong. The right answer was minus 4 and 3. Let me check. So minus 4 and 3, and 3 was the most common one. There was also 3 and 4, which was correct as well, of course. But minus 3 and 4, as I said, I got it wrong. I'm sorry about this one. But as you can see, some of you guys did the same mistake by basically switching the signs, which happens, but it's always important to check the details. Okay, don't solve this equation, but find the values of a, b, and c. So what do I mean by find the values of a, b, and c? I simply mean when we have the basic expression for a quadratic equation, we have ax squared plus bx plus c is equal to 0. So we need to have that expression, that structure, to find a, b, and c. So the first thing I do is I multiply by -6 on both sides, on the right-hand side and on the left-hand side. That gives me -6x squared plus 36 is equal to 2x plus 12. I bring the 2x to the other side, that becomes -2x, and I bring the 12 to the other side, that would give me 36 minus 12. So a, b, and c are -6 for a, b is equal to -2 because I brought the 2x to the other side. So -6 minus 2 and 24 because we had 36 minus 12, which is 24. So -6 minus 2 and 24. And most of you got the right answer. So once again here, for those of you that got the wrong answer, it's probably a mistake with the signs. Maybe you didn't take the minus sign into account or something. So it's I did a mistake myself in the question above. So it's always really make sure you have the right signs and that you don't get the wrong minus or plus sign. Okay, that was it for this Microsoft quiz. Okay. Wait, there's some people saying that the last one is false. Okay, maybe I could do the last one on PowerPoint just to make sure we agree. And then I've got another answer, another question that's quite interesting as well. Another question, sorry. Okay, let me share my PowerPoint. There you go. Okay, so just to check that I got the right answer this time. So first thing we do is multiply by -6 on both sides. So on the left-hand side, this becomes -6x squared plus 36, because -6 times -6 is 36, is equal to 2x plus 12, because on the right-hand side, the -6 just cancelled out. I bring the -2x, I do -2x on both sides. On the right-hand side, of course, it cancels out. But on the left, I get -2x plus 36 is equal to 12. And finally, I do -12 on both sides. On the right-hand side, of course, it cancels out. And I get -6x squared minus 2x plus 24 is equal to 0. So A is indeed equal to -6, B is indeed equal to -2, and C is indeed equal to 24. So yeah, careful with the minus signs. When you multiply, it's make sure you have the right ones. Okay, then I have quite an interesting question where basically what you're going to have is a quadratic expression inside another quadratic expression. So we have here an example, x squared minus 4x plus q is equal to 0. The question is, find the values of q such that there are two solutions to the equation. So I want to find the value of q such that this equation has two solutions. So what is the condition for the equation to have two solutions? We know that b squared minus 4ac needs to be strictly bigger than 0. That's the condition for two solutions. So b squared in this case is, what is b squared? B is minus 4. So I have minus 4 squared. Minus 4 times a. A in this case is 1. And c in this case is our known, it's q. Bigger than 0. So I have 16 minus 4q is bigger than 0. Okay, so what I do here on both sides, I do plus q plus 4q on both sides. On the left hand side, it cancels out, and I'm left with 16 is bigger than 4q. And finally, what I can do is divide by 4 on both sides, such that I get rid of the 4, that's the coefficient of the q, and I'm left with 4 is bigger than q. So in order for this solution to have in order for this equation to have two solutions, q needs to be smaller than 4. So that's the condition. Okay, if we now take this equation and look at what it looks like on GeoGebra. Let me share my screen. Sorry, every time I leave the presentation, it stops sharing screen, which is annoying. Share my screen. There you go. So what I had was x squared minus 4x plus q. So what we said was that if q is smaller than 4, we would have two solutions. So what happens if q is equal to 4? You see that if q is equal to 4, we have only one solution. We only have one root. If we have q is bigger than 4, for example 5, you notice that there's no solutions. Now if q is smaller than 4, which was our solution, for example 3, notice that immediately there are two solutions. So our answer is correct. Q needs to be strictly smaller than 4. Even if we're very close to 4, but still smaller than 4, we still have two solutions. So this is also an example questions that you might have, is find the value of a certain certain unknown such that your quadratic expression has two solutions. I could have asked also such that your quadratic expression has one solution or has no solutions. It's a similar problem. Okay, let me check the chat to make sure there's no issues. So for the last question of Microsoft Quiz, of course, because it's equal to 0, you could have multiplied by -1, you could have multiplied by anything, but so it wasn't the best question. You know that sometimes Microsoft quizzes, it's quite hard because I can't really see your reasoning, so it's quite hard to ask the right questions. So that's why if you multiply by -1, of course it's totally fine. If you prefer having the a value that's not equal to a negative value, then you could multiply by -1, so that's totally fine as well. Those Microsoft quizzes, they're not really graded or anything. It's just to really interact with you a bit more. Okay, I'm just looking at the questions.
So as someone pointed out, that's why could have happened is that people just switched the minus sign in order to avoid having an a that's a negative value. Okay, people are asking about question 8. So I do question 8. Was that the one from the Microsoft quiz? Okay, so for question, there seems to be a bit of confusion about question 8. Let me share my screen. Okay, so question 8 was, so this one. So what we have at the end of, once we rearrange our equation and do have ax squared plus bx plus c is equal to 0, we can now try to solve this equation. So of course, some of you here, what I did is a equals minus 6, b equals minus 2, and c equals 24. But as some of you have done, is what you did is you multiplied by minus 1. So if you multiply by minus 1, of course, 6x squared plus 2x minus 24 is equal to 0. So of course, then our a, b, and c change in this case. So that's why some of you had a different value to a, b, and c. Because what you could do as well is then to simplify, you could divide by 2. If I divide by 2, I could simplify again my expression, because 6 divided by 2 is 3, 2 divided by 2 is 1, and 24 divided by 2 is 12. And then 0 divided by 2 is simply 0. And then my values for a, b, and c change once again, because here now the values for a, b, and c that I have, so that was for before, now I have a is equal to 3, b is equal to 1, and c is equal to minus 12. So you see how they changed just by manipulating the expression. So that's why my question in the Microsoft quiz was a bit confusing and not the best one. When you have such exercises, such topics where it all relies on the reasoning behind the calculation, it's hard to do a Microsoft quiz. Anyway, if we now want to solve this equation, so we have 3x squared plus x minus 12 is equal to 0. So what I could have is just use the quadratic formula, minus b plus or minus square root of b squared minus 4ac divided by 2a. So in this case, b is equal to 1, so minus 1, plus or minus square root of b is 1 squared minus 4 times 3 times minus 12. Oh, there we go. Divided by 2 times a, so 2 times 3. What you're left with is minus 1 plus or minus square root of, so you have 4 times 3 times 12, that's essentially 12 times 12, and plus 1. So that gives you 145. Divided by 6. So now if I look at what this looks like in GeoGebra, I might show you something else as well. Okay, so if we look at
the way this looks. X squared minus 6 is equal to, so I simply plug in the expression x squared minus 6 is equal to, and then I have a fraction, 2x plus 12 divided by minus 6. Oh. X squared minus is equal to 2x plus 12 divided by minus 6. Okay, this doesn't seem to work very well. Let me just plug in the value we found. 3x squared plus x. So 3x squared plus x minus 12 is equal to 0. As you can see, once again, we find two values. So of course, I didn't expand the values we found, but we saw that the b squared minus 4ac was different to 0 and was positive. So necessarily there had to be two solutions, two roots, and this is what we find when we look at the graph. Anyway, that's similar to what we've done before, so it's not news to you guys. Okay, sorry, I was just very looking at the chat because I don't have much time left. Okay, so as a last thing, maybe I could go back to my PowerPoint and look at the last thing I did, which was this one. So there seemed to be a bit of confusion about this question as well. So I had as an example, x squared minus 4x plus q is equal to 0. So q is some constant, is some number. The question was, find the values of q such that there are two solutions to the equation. So what is the condition to have two solutions for a quadratic equation? It's for b squared minus 4ac to be bigger than 0, to be positive. You remember from the slides before, if it's positive, the plus or minus has an important role, so you have two different solutions. So in this case, a is equal to 1, b is equal to minus 4, and c, what is c? It's simply q. It's our constant, that's here. So b squared minus 4ac becomes minus 4 squared minus 4 times 1 times q. So minus 4 squared is 16, minus 4 times 1 times q is just minus 4 times q. We add 4q on both sides, so minus 4q plus 4q on the left, it just cancels out, and on the right, you just have 4q. So you have 16 is bigger than 4 times q. All you need to do now is divide by 4. So you divide by 4, you go from 4q to q, and from 16 to 4. So what you're left with is 4 is bigger than q, or I can rewrite it as q is smaller than 4. It's the same thing. I just switch the order. So 4 is bigger than q is the same as q is smaller than 4. So you could have many questions of this type. You could also have, for example, you could have the q in a different position. You could have q x squared minus x plus 2 and find q such that there are two solutions. So you would do the same thing. You would do b squared minus 4ac is bigger than 0. So b squared in this case, we have a is equal to q, b is equal to minus 1, and c is equal to 2. So b squared would be minus 1 squared minus 4 times a in this case is q, and c in this case is 2. So we'd have 1 minus 8 times q is bigger than 0. You bring the 8q on the other side of the sign, you get 1 is bigger than 8q. You divide by 8 on both sides, and you get q is smaller than 1 over 8. So you could have many different questions. They could also ask find the value of q such that there are no solutions, or find the value of q such that there's one solution. They could also put the q here for b, and if the value of b is q, then that would make it a bit harder, because in our expression b is put to the power of 2, so you would have q to the power of 2, and you need to solve then another quadratic equation. So it can get quite tricky quite quickly. So that's why understanding the basics is so important, because quite quickly it can become very tricky suddenly. Okay. So there's only 3 minutes left. So I'm just going to quickly check the chat, and make sure there's no more confusion about anything. Of course, I couldn't answer all of your questions because there's still 130 of you. But okay, someone asked me, could you try sine of y is equal to cosine of x? I don't know if I can write this on GeoGebra. I'm curious. Let me try it. So sine of y is equal to cosine of x. So sine of y is equal to cosine of x. Oh, there you go. So it does work. And this makes sense because there's an infinite amount of values where cosine of x is the same as sine of y. And they put themselves in straight lines. Because, for example, if you have pi over 4, you have x is equal to pi over 4, y is equal to pi over 4. That's an example of a solution. So there's an infinite amount of solutions. And also, when you go into loops, you can imagine that it can just carry on going around in circles. So that's why there's so many solutions. That was just someone asked me to plot this in GeoGebra. Okay, anyway, I won't hold you for too long. Thank you everyone for attending the lesson. You can now leave, don't worry, I won't be going through any more content. I'm just looking at the questions. So I don't understand why you're using only the b squared minus 4ac part of the quadratic formula. Because b squared minus 4ac is the part that defines whether the quadratic formula has one solution, two solutions, or no solutions. I can show you if I get back to the summary slide. There we go. Here, if you look at the quadratic formula, b squared minus 4ac, if b squared minus 4ac is negative, then you don't have any solutions because it's within the square root and you can't have anything negative in the square root. So if b squared minus 4ac is negative, you don't have any solutions because the solution does not exist. If b squared minus 4ac is equal to 0, you only have one solution because the plus or minus suddenly becomes useless because plus or minus 0 doesn't change anything. So that's when you have one solution. And if b squared minus 4ac is positive, that's when you have two solutions. So this is why this part of the formula is so important, because it defines if the equation has none, one, or two solutions. Okay. Well, as it's the last lesson for me with you guys for this year at least, I hope your exams are going to go very well, and that your revisions are going to be very productive. I hope mine are going to be as well. So yeah, everyone can go. Thank you everyone for this year, and maybe I'll see you next year if I get the year 12 students. So thank you everyone, and maybe see you tomorrow for physics. Bye.